Just I am live. Looks like I am live. Yes. RoboCup. Okay. Okay. Can I end the stream?
Not sure whether you got connected about voice and the microphone.
We need to test the video. Participant messages, live reaction, message delay, live chat.
Okay.
Visibility, private. Okay. Can you try to enter the live stream? This share privately.
Google Meet lasts that long.
Google Meet shouldn't have a.
Google Meet got time limit if you are not if you are free.
Is there a time?
I think if we use our education email.
Oh, okay, yeah, education email that's on.
Okay.
I did not see anything.
I left it as unlisted.
No, because you leave it unlisted, right?
Yeah. So maybe I need the link.
Or you send me the link first before you.
It's okay. I'll just make it public. Okay. See if you can check it out. Scroll setting. Closed captions. Yep. Okay.
You can ask us if something. I can hear my
Welcome to the live stream. Can you hear anything? Delay?
The sound and the screen will have something.
Can I see? No.
Ultra low latency one.
Which one?
Go to the Bluetooth side.
Okay.
Now we can. Maybe you change to this.
Oh.
I think we need to cancel.
Oh.
No.
Okay. So end stream.
No, do you change or
I have to change this to ultra low.
I think I'm not sure that Wi-Fi can support it already.
What am I on now? UTM Wi-Fi? Yeah. Stream current bit rate is lower. So it's a bit laggy. So for
Just put it together with the
A few to 5 seconds.
3 to 5 seconds. You mean
Yeah, so when I'm speaking here, it will actually up from the left ear.
okay? So what I can do is I can offset the audio. I think we take in the desktop mic. How was it? Can you hear anything? Test. Mic test. Can you hear me? Seems to be. Mic volume. Hello. Hello, test. 300.
I think that's a frequency, but as long as working for us between when you talk and the
Okay. I'm gonna say something and I'm gonna open a page and then you see if the thing
whether it's
matches.
synchronous or
Okay, ready? Change page. Can you hear me? But it's synced up. It's synchronous. Okay, good. Yeah. So it's a little bit delayed, but that's all right. Uh, okay, doctor. So the first, what would you like me to show in the terminal lesson? What do you like that people would use? Okay.
Anything that I'm with the
Are you going to be moving around during the workshop?
yeah, it depends. But the explanation will be on this. If I do the demo, then maybe it will be like on the robots.
Okay, then maybe you can just guide me if you want me to.
I think because the screen is over here, so when I do the demonstration, it will be over here. Okay. Right, so this is a robot. So when I want to do any demonstration, I'll come here. Right, or else I will be like speaking over here. So when I'm speaking, you don't need to see at me. You just look at this. Books, you have book, right? Yes, yeah. So one will be on the screen and one will be on the screen.
So the first step will be
Probably over this side.
yeah, and then I will.
This, I think that you can shoot from here.
Sure.
That's exactly good. And you try to guess which one is.
Okay. What is it?
Because to change the layout makes a very small of the table.
Yes, that's what I want to say.
Yeah.
That's why you need your people to be here. They need to divide you into at least 6 groups.
6.
How do you 6 groups?
I think that's the possible error one to be open. What's the use the Cairo Wi-Fi?
Okay, just tell me. No, you just tell me. Okay, so tell me how to set up.
Okay. Can I give you the meeting link?
Yes.
Okay. The link is meet.google.com. 9 letters, doctor. The first three is DWA dash ZZBA Buffalo America API. Yes. Admit. Okay. Please share the screen and then
So I didn't need to
you can turn
show.
off your webcam.
Yeah, and my mic also, right?
Yes, you can turn off your mic. That's right. Between windows, then maybe ah, then maybe you share your whole screen then. Uh, that's true. It's okay, doctor. If you are going to be changing, you just change to a different window. There's going to be a slight delay, but it could be. Okay. Can you increase? Wait. The resolution is better.
Yes. And then you can like shift the table so that all of you can use it. Yeah, move, move, move. It's very hard for you to follow if you still like that. It's very hard for you to like tires and discuss with your teammates. So okay, I need you to divide yourself into 6 groups, please. Hurry up.
Teach.
Okay, we need extra.
Yeah, you organize yourself so that you can 6 groups separately and comfortably. Okay, you're going to follow me and type the code and everything. So make sure you're comfortable with the arrangement. So about 3% per group, right?
And maybe we could move this table up this session. Okay?
So you have my screen, right?
Yes.
Okay, good. So maybe
Let's just be slowly. Okay. No, no, turn that way, by the way. Go, let's move. Go, go. Keep going.
It's not that long, but it's not.
the more this thing back if you need more space. Good. Yeah, pull the table, but be careful on the table. Can you help like can you help like just be careful on the table down there. Make sure you don't like okay. Okay, right? Yeah, okay. Done? Is it enough? Okay, right. Listen back. Okay, we're gonna do the next one. This one power. Yeah. Go figure 3. Six. Okay, yeah, okay. This one looks better. So we get a little bit.
I make it small. Still big.
That's why it be yellow.
When
Still settle, please sit down.
excuse me, can you help me move this?
Am I screaming, right? Yes, right. No, you're screaming, that's right.
Yes.
Okay. It's the face I can bring my one here. Is it better if I show it over here?
Yes.
Is that correct?
Yeah.
Okay. So I'll be showing like this. So I can explain like this.
No.
Yeah, I I said like this. Yeah, I'll do that. Sorry. This.
Candle.
Good.
Good.
Well, yeah, so before we start, I need to do some logistics. Right, so I'm excited of this. This is what I call Jupyter IO. Right? So this system, something like over there. If I explain to you, then yeah, maybe I pass to you. So each of your team, select one representative, team leader, whatever, and take this one. Right, and you hold responsible to take care of this thing from today until tomorrow. And we have to be what I show you, pass you now. Okay. Right. Good. Right. So, yeah. So if you want to take this from me, you need to return in the same region. Last one more. Right, so this is the repeater. I hope I will tell you what to do. Okay, and then I have three of this. Okay, that's it. All these three, they are working right. Because they say like need to what this lithium battery. Is it? Right? Okay, right. So since I've got six of you, but I only have one Q3 and one RoboCup. So we have four. So I need volunteer. Who wants to play with this, play with this, play with this, and play with this? Yes. Yeah. Put up your hand, whatever they come first. Tell me which one you want. How do you pick? Do you want to use this or what? Do you like? I need to explain this. Which one? Okay. Well, so this one you're using. Okay. So who want to use this? Confident? Okay, you guys want to use it, right? Okay, but I can very fast with you after I explain it. But most probably you will be using this tomorrow. Okay, and anyone that use this, I have higher expectation. Okay, because you need to show some demo tomorrow. Okay, right. Okay. So let me explain to you why I passed with it. Okay, so first, for the IO, I'm not sure what system you use in your laptop now. Everyone with laptop? Okay, anyone with Windows? Everyone? Anyone with Ubuntu? So you have global or what? Okay. I want to know that your Ubuntu and Windows is global or virtual, right? Or VMware? VMware. VMware. Okay, I don't want to count. VMware not count. Okay, VMware not count. Global. Who got global? Yeah, global. What version? 20. Okay. Not using it. Because like the single version that I introduced to you is 18 or 4. So nobody Ubuntu anyway. Right. So this system,
Just watch the camera.
this robot is currently running on the system. We call it Jupyter I/O, but basically it is Ubuntu 18.04 with cross Android. Okay, and all the configure, all the software and everything to move the robots. Right. So we'll be using this as a reference. Later on, you want to update your system to 20, it's up to you. Or even if you want to use ROS2, it's up to you. I'm going to tell you like ROS2, how you do it, but that is not the content for this workshop. Okay? So that later. So this workshop is standardized to 18.04, Ubuntu, and then ROS Melodic. Okay. So since nobody has this system, so you use this. Okay, so why we use this is because inside here when you open up, you should be finding one things like this. Okay, so this is what we call the Jupyter I/O. Right, and I need to say thanks to Jupyter Robot Company to sponsor this, so that I can bring this and let you test. Right, because like Jupyter Robot has been like our sponsors for this event, RoboCup at Right, so how to use this? You can see that you can open this thing up and you have USB cable. Okay, so this one, first, you take out the antenna, you fix the antenna, okay, so that you have strong Wi-Fi signal. Okay, with this antenna, or else you cannot connect to Wi-Fi without this antenna. Right, so this is the first thing. Second thing is, you have this is what we call the extension cable. You can use it or you are not, you can use it without this cable as well, but I just want to demonstrate to you how to use it. So this extension cable is for you to extend this like this. So this thing can plug to the PC. Okay, but sometimes after the extension, it might not able to recognize or something, then you can remove the extension and connect directly. Okay, and try again. Okay, but if possible, try to use the extension cable because like later on, if you want to fix on your robot, for example, you might need to pull this and so on. So use it when you need it. Okay, this cable. You understand what I mean later on when you use it. Okay, right. But try not to like fix this directly to your computer and you try to move this because anything this thing lose, you will lose the system if it is on random. Because you need to connect the USB all the time and be running the OS inside it. Right. And halfway you unplug this while it's running, it's hurting the SS media. Okay, so to do that, make sure you don't make sure that this is a firm connection to your USB port once it is running. Okay, so if you need to move this, use that extension. Understand? Right. Okay. So after that step you select one representative to use the PC. Right. Connect this to the fastest USB port that you have. Maybe the one with the blue color one, USB 3. And then try to go to your BIOS and boot from this device. Okay. Right, you understand, right? Boot from this device. And once you successfully boot from this device, you will get the system similar like this. Okay, so we can try that one. Okay. So for the iPhone, I only can bring like one for each of you. So the rest of you can take turns to do the hacking later. If you have I don't know your virtual drive or whatever, yeah, you can have your virtual box or VMware that you can have. Yes. But you are not having this in Windows. You have to go to the BIOS boot from this thing. After you boot from this device, you will get the Windows. You understand? Anyone not here? Anyone know what I say? Know how to go into the BIOS? It's either in the delete or F12 or in the depends on the PC. Go to the BIOS, select the boot sequence so that you boot from that device. The device called Jupyter I/O. That's what I need to try now. Anyone else? If you don't know how to enter BIOS and you are currently in Windows, please recovery option. Okay, you can use that to enter your BIOS. Yeah, press recovery option. Okay, you can just don't lose the this is okay. You go to recovery option and advanced startup, you will say restart, and you should be able to find one option to boot from.
This right here is how you delete sources in OBS. Super quick, super easy. All you gotta do is go to it, right click on it, and you can simply go to remove.
Okay, so once you are in the recovery option like this, you go to troubleshoot and you go to advanced option and you go to this. The video recording. Okay, then after that, you go and look at your boot sequence to find where is the Jupyter I/O. I hope it's appear there. Can you find Jupyter I/O? Okay, so if you cannot find Jupyter I/O, but you saw something like Ubuntu system selected, Okay, but I just saw that it ran from there. Option 2. Option 1. Okay, okay. Set it and try to reset. You set the Ubuntu or Jupyter IO to the highest in the boot sequence and then restart and it will boot from the device itself. In the BIOS, you cannot see anything like Jupyter IO or cannot see Ubuntu. Most of the cases, maybe you need to change the laptop. Because the laptop is not recognizing that you are. Right, so once you enter, you can see something similar like this, which means you already have all the software set up ready for you to follow the workshop. So the system will be Ubuntu 18.04 with the ROS logic and all the software that is already configured. Yes. Is everyone into the system? Okay, so that is first thing. So after you have successfully put into the system like this, this is what I say, the USB, you need to be very careful, you don't like take it or then I feel like when it unplugged, then things will be nasty. You try it. Yeah. Let's try it. So once you are in the system, I want you to log into this robot for all. Okay. So go to robot for all, the one that I sent to you, and then make sure that you enroll into this course. So once you are in Ubuntu and the rest of you can do the same thing. Go to this website.
Can you switch screens after the mix is showing the other window? Not showing that one.
Doesn't change anything.
Stop sharing and reshare.
Oh yeah, alright. So I think this is around the
Okay, that's fine.
可能他找不到 driver， 或者是你的 motherboard 不适合，有可能他找不到 motherboard， 该可以啊，因为纯人民不是有，还有可能你有 GPU 吗？可能他找不到那 graphic card， 所以他有，你可以 try to enter safe mode， 看他可以进去，如果不可以的话，可能你换下点。等一下我们再来看怎么换。Okay, right. So the next thing I want you to enter this website. I hope you already signed up an account, log in, and then enroll to this course. Right, I want you to see this. Right. Okay, so once you select this course, you will be into this page, right? This one, right? Okay, so in the curriculum, we have 5 modules, 5 sessions this time. So I will be covering this content for the entire 2 days. Okay. So starting from service robot development, then speech interaction, visual perception, navigation, and system integration. Right. And roughly about like one sub-module is about 1 hour. So we have quite a lot of things to cover, and you also need to be hands-on. So I hope you can Make sure you follow up all the time. Right. So everyone please log into that. And if you click on the first one, system setup, you should be able to see this screen. Okay, and then you can full screen that. Yeah, you know you full screen and do that. You can do that. Okay, this is the details. For the rest of you that do not connect to the I/O, you can see this as well. Just log in this website from your Windows. Yeah, I want all of you to put up your laptop, at least you are looking at something. Okay? So, right, okay, everything okay?
Oh, but doctor, Google Meet is still stuck on this page.
It's because the day is something.
Sure. Try to reshare screen, doctor.
Share the screen, entire screen with one share.
Okay.
Okay, so is everyone ready? Okay, so one of you in your team supposed to be on the Ubuntu system, and you boot up the Firefox or whatever browser, and you are in there. Okay, and for the rest of you who are using Windows, also access to this. And if you have the virtual box or VMware, you can run Ubuntu and follow some of the course. Okay, because you need the Ubuntu system in order to do the development. Okay, so anyone have any problem following up to this point? Anyone? Anyone have any problem to follow? Everything is okay? Right, so let me start with the course. Right, okay, so let me introduce this course. So for RoboCup at Home Education, we try to run this kind of workshops and also online classroom every year, right? Starting of 2020, we started this online classroom, but this time we try to have local workshop as well and incorporate with the live streaming so that the local audience and also the international audience can join this together. Okay, so over here we have this, and thanks for providing this venue and also participate in this workshop. So for this time, we are going to do this, what we call the open platform workshop and online classroom series over here. Okay, this time. So on the span of 2 days, I'm going to show you what previously we have done in 5 weeks. So it's how to say, we compress all the course into a solid 2 days intensive course. So hopefully, like you can follow up with me so that we can finish everything within 2 days. Okay, right. So for the first part, I'm talking about service robot development. So I'm going to show you how to develop service robot. Okay, why I'm showing this is because like for this at home education, we are promoting service robot development competition. So we have a competition called at home under RoboCup that is promoting robot that assisting human in a daily life environment. For example, in a domestic environment, for example, like in your home, or something non-industrial. For example, like in the hospital, in school, retail, shopping malls, and so on. So in domestic environment, the robot is helping people, is providing service. And this kind of robot, we call it service robot. Right? So this course, I'm going to show you ways how to like set up a simple service robot system so that you can start this kind of development. Okay, so that is the introduction of this course, and I hope like you can enjoy this course together, right? And also down there, I list down all the sponsor. I need to say thanks to the sponsor for RoboCup and RoboCup 2023 LOC to support this event. So we are going to host an international competition. We call it the at-home education challenge during the RoboCup 2023 this July. Right, so I welcome you all to join also because we have the online version. Right, For more detail about RoboCup at Home Education Challenge, you can head to the website www.robocup@home.edu.org. You go to the website is over here. I show you, this is the website. Right, so over here you can enter this and you can find all the information about the competition, the one in front. And over here, we actually done a webinar last month, and you can find the video explaining the whole process, how to join the competition, and what kind of category we have inside there. Right, so should be one of the categories is something that you can join, and you're still able to join because like the closing date for the guided track is actually end of May, May 31st. Right, so you still have time to entry for the online challenge. Right, so I encourage you to send in team to join this. Right, so over here you can see, you can find all the information from this side. Right, okay, so go back to the. Right, and then the second things I want to say thanks is also for Jupiter Robot Company. So Jupiter Robot Company have been supporting this event ever since the starting of this education challenge, and today they actually provide me with this robot, all right, and also the I/O that currently you are using for this workshop, right, so that you can experience like how to learn this thing without actually having the hardware yourself. Okay, right. Okay, so I'll be using this as a reference, but for open platform means you are encouraged, no, you should develop your own robot. Okay, you should customize your own robot. You should be able to have the know-how, what kind of component and how to assemble them together to build a service robot. So that is the purpose of open platform challenge. Okay, so for Jupiter Robot, they are actually showing this system, which is very similar to the Kobuki base, which is the Turtlebot 2 system that you have. You can see it's something very similar. Okay, so you build up on that. And in this workshop, I am showing you the way that is actually not depend on this system. Okay, I will also show you how to use your webcam, how to use your microphone to actually do the functionality of the service robot. Right, so you are totally free, and our effort is always to make all this knowledge and all this component open. Open means open source and also open architecture, so that you can actually eventually build your own robots or extend this system to some other that you're working. Right. So I hope this course is not just to show you how to enter the competition, but eventually you can use all this information and all this knowledge to apply in whatever engineering projects that you are going to do after. Right, especially the vision, the speech part, you can actually do in many innovation competition or innovation project as well. Right, so that is the purpose. Okay, we are actually promoting this learning and not want to sell you things or things like that. Right, okay, so that is the spirit of this competition, is through this competition and through all this hardware and software to show you how to learn build robots. Okay, right. So first thing is I already mentioned the workshop and online classroom information. So the slide other than the RoboCup, Robot for All website, you can actually go to this workshop and online classroom 2023 to actually find out the slides that I'm presenting here. Right, so you can see the slide. But today we have the live stream and the video later on we are going to edit, so that we can couple the video and also the course material together, and we'll put under the classroom courseware. Right, so that is inside the Robot for All website. Okay, and you can actually sign up an account for free and enroll for the course for free. So no worry, you can use this for reference. Okay, so for the first part, service robot development, I will divide into two parts, and we are going to settle this course, this section within maybe 2 hours. So what is the time now? Now it's about 9:30. Okay, just nice. About 11, hopefully I can finish your ROS basic and you can start your first exercise. Okay, you are going to have a lot of exercise, so make sure you prepare yourself well. Okay, right. Okay, service robotics research and development. So first, let me introduce what kind of research work or research content that involved in this development, and what other things or what kind of R&D things that you can do for yourself. Okay, so I share with you some examples that I have. So for this service robot platform, the platform that I use, it divided into these 5 components, right? So, namely, the first component is the robot mouse at here. Okay, the mouse is over here. This one speaker, and then the ear is over here. We have the microphone. In fact, we have several microphones around. Right. So this is for the, and not just this, because like we connect this to the sound card and then you need to do processing, you have the software, etc. So this speech interaction module is for human-robot interaction, mainly. Okay, but we also have a screen here. You can do some GUI later on for the human-robot interaction as well, to enhance. Okay, so that is the purpose. Because for service robot, the important thing that distinct or separate this service robot compared to other, for example, like industrial robots or other machines, is the interaction part. Service robot, very important, is the robot has to have certain amount of capability to interact with humans. Okay, previously maybe like for your fridge or for example, like one of the example, the Roomba. Okay, you have the Roomba. So the interface is just the button maybe, or maybe the touch screen or app. So that is very conventional human-computer interaction or human-computer interface. Okay, but for service robot, it needs to be more proactive, which means the robot actually proactively interact with the human. Like it can actually speak to the human. Maybe you can say like, hey, well, my ATM machine also can speak to me, right? So ATM machine also somehow like have those kind of interaction interface. So we are going to use that interface to actually make service robot much more engaging, so that you can actively engage to the service robot just like how you engage with people. For example, in a restaurant, you might want to expect in future the delivery robot, you know, like in the mama robot that you know, right? The service robot, the delivery robot that in the restaurant. Maybe eventually it may be able to work something like the waiter or waitress. Maybe you can take order, you can ask for something like you can ask for menu, extra dishes, or you have any problem, you can straight away like discuss with the waiter and waitress, right? So eventually maybe you can do that with the machine as well, with the robots as well. Okay, so that is the human-robot interaction part. So I'm going to show you how this thing. Then we have the robot eye, which is the visual perception. So it is also very important for service robot to understand what is happening in the surrounding. Okay, service robot and industrial robot, I always compare service robot with industrial robot so that you can see the difference. Industrial robot is when we design, we tell the robot exactly how the environment will behave. Like how big is the environment, what kind of things that is moving around, what is the boundary, and so on. And we will make sure that there is no disturbance. We even fence it up so that it can work without any disturbance from external. Okay? But for service robot, it is very important for the robot to understand what is happening surrounding dynamically. For example, the delivery robot in the restaurant. You can never know like when some obstacle will happen, some people will walk past, and then you can also you cannot also like program everything that is going to happen on the robots, because a lot of a lot of things can happen. Like different people can move past the path, block the hallway, block the walkway, and so on. So the service robot has to have the capability to adapt itself to the environment, rather than the other way around, which is we design, we control the environment so that the robot can work within the control environment. That is for industrial robot. But for service robot, it is the other way around. The robot has to see what is happening in the surrounding and have the capability or the intelligence to adapt itself to the environment, the changing of the environment. Okay? Right. Okay. Then the third one, of course, the service robot mostly is able to move around. And not randomly move around, but it knows where it is, the localization and so on, so that it can do the task according to the location. For example, you can ask the robot to go to somewhere, do something, and then come back. So it will aware of this spatial environment, and then it can also plan itself to move from one point to another point. Okay, so that is very different. So that example already showed, demonstrated by your floor cleaning robot, your Roomba, right? Because the Roomba know where it goes and know how to move from one point to another point without collide into anything. Right, so that is the autonomous navigation. And eventually, if you extend this capability and you put in, like, for example, GPS system, then advanced stuff into it, then you have your self-driving car. Right, so that is the advancement of the technology. Right, so it actually starts from mobile robots. Right, then you extend, you use the mobile robot technology into service robots so that we can make the robot. But in comparison with industrial robot, you hardly see any industrial robot that is move around except AGV. And even AGV also traditionally a follow line, the magnetic strip. And then now only recently they have this AMR, right, or something like that. So that is slowly it actually changed because we can see that as our mobile robot technology advanced, it is slowly we find out the value even in industrial environment. For example, like it can do the sorting, it can do the warehouse automation and so on. Okay, but we are using this in a more challenging environment. For example, on the road. So that is a self-driving car. And then we also use this technology in very, how to say, dynamic environment. For example, restaurant. Restaurant is a very noisy environment, right? You have a lot of obstacles, you have a lot of people walking, or in a mall, in a train station, and so on. So we have the service robot that move along this line for the autonomous navigation technology. All right? Okay. Then, of course, we also need an arm. Okay, you might say like, okay, the object manipulation maybe is the expert in industrial robots, but in autonomous robot or for service robot, it needs the arm to actually do something more advanced. For example, like mobile manipulation. Okay, for mobile manipulation, it's actually a new branch in manipulation research that we focus on solving how to actually grab something and change the position of the base. Okay, and because that is very similar like human. For example, in industrial robot, we're talking about the working envelope. I'm not sure if you have taken your like robotics course that talk about like Jacobian metrics about how to do the inverse kinematic and so on. So that one is limit to you always have a fixed space, right? Okay, but what if this fixed space is another big equation, the mobile platform equation? Then it becomes you have the inverse kinematic equation plus the mobile platform equation, and you combine these two become a new research, the mobile manipulation research, right? So for example, like human, our arm is not as strong and also as long as the industrial robot arm, right? But what we can do is we can move. For example, we want to take something from there, we can move that, although our arm is not long enough. And also, if one arm is not enough, we can do two. And we can interact with more people to actually do it together. So that is the intelligence when you combine the arm technology with other technology, the movement. Okay? Right. So that is the difference of mobile manipulation as compared to the industrial robot. Then lastly, of course, very important, in order to do all these things, we need very strong intelligence. Right. As I said previously, in industrial robot, we try to have a control environment so that the robot no need to process so much thing and do the job efficiently. Because for industrial robot, the objective is to be fast and efficient. No less error and then fast. But for service robot, the criteria is not about speed. Right? For example, I ask you, which cafe you like? You are not going to say, oh, I like this cafe because the worker work very fast. Right? Maybe you said, okay, the waiter or waitress are very like kind, helpful, very cheerful, and you like it. So the how to say, the benchmark of the definition or the requirement or what we want to achieve in service is not about speed anymore. It's not about efficiency anymore, but more on other things. For example, is the waiter or waitress very attentive, very adaptive, and so on. So these are the quality that we look for service robot rather than industrial robot. So they are like two different benchmark or two different development. So when you develop service robot, it is not just about efficiency or just about productivity, but more on how good is the service. And when you say how good is the service, everyone actually got different preference, right? For example, like when you want to build a service robot, you say, okay, this robot is very smart or very useful. Okay, and different person might have different criteria. So in order to make your service robot very adaptive or good for the work, we need a lot of intelligence. And for example, over here, for example, we apply machine learning, we apply AI. Why? Because for example, I give you one example. If you want to build a robot for the retail, for example, okay, so for the retail, you need a lot of interaction with the customer. For example, like you need to give recommendation to the customer, you need to look at the feedback from the customer on the spot and give suggestion and so on. And this kind of things, a song or play me a song. Which version? It's actually earlier than that. 8. Yeah, 8 maybe. It's actually much earlier. If you look at Microsoft research, the Microsoft speech, they call it the SAPI, API, the speech API, is actually quite long ago. Microsoft actually started this voice research very long ago, and they have quite a lot of very good research in this speech part. And currently, they also bought the ChatGPT so that they can go beyond this interaction part. Right. So for speech research, it's actually a very traditionally very AI stuff, and a lot of things have been happening inside. So if you're interested in this human-robot interaction direction, so we can actually do a lot of research topic and also development inside here. Okay, so we have synthesis, we have recognition, online, offline, and then we have also the facial expression, etc., etc. So these are all the things that is involved. And for example, for my research back then with my student, so we actually try to figure out how to actually let robot learn how human talk to another human. Right. So when you talk to another person, you have the gesture for example, when you say something, you have a certain gesture, and the gesture actually has some value or meaning. Okay, so how to learn that? So my student actually used this paper. So this paper robot is another platform that we use in atHome, which is more expressive. It's a very human-like movement that can mimic human behavior. The body gesture. So we use the generative machine learning techniques to actually learn from human interaction movement when it talks to another person. And then after that, we ask the robot to learn from the human so that when the robot talks to another person, it will try to mimic how I express myself in the same context. Okay, so this one involves a lot of machine learning stuff. And then it can self-generate new human-like gesture when talking to another person. Right, so these are. So for human-robot interaction, actually a lot of things to do. Not only the things that you say, but also the meaning that you try to express. Right. Then the second one is I. I think this one, a lot of you may be interested or you are working on. Right. So we have different kind of sensor. For example, like the IO that currently you're having, that is actually an RGBD sensor. You know RGBD? So over here, the robot, we have two, this one and this one. This is an RGBD sensor, which is not only it have the color information, like your USB cam or your webcam, but it also have the depth information. Right? So combining the depth information, for example, like this information, with the color information, we actually have more information about the environment. For example, your phone, your Face ID, if you show your face photo to the phone, it's not going to unlock, right? Because the algorithm is more than just color, right? So you need the shape of your face, then only you can recognize as the Face ID. So this is something that you can do with the IO, with this kind of sensor, right? Okay, so I'm not sure which sensor you're familiar with. Maybe Intel will sense. We have a lot. Like in the earlier day, you have the Microsoft Kinect. So Microsoft actually, again, they bring in this breakthrough to the robotics and also the community to do this thing. So this actually gives you a lot of rich information for the robot so that we can apply a lot of techniques to understand the environment. Okay, because for our eye, actually how human perceive the environment is purely based on color. You know why? Because our eye can only see color. Can you measure what is the distance with your eye? You cannot. Okay, how you measure is you try to use your television. All right, you try to use a stereo because your mind know that how far these two apart, how far these two, the location of these two, and then you try to calculate like when I look at this point and when I look at this point, what is the difference, and calculate estimate the distance based on that. Do you know how stereo vision works? All right, so one kind of this kind of sensor, we have the stereo vision back. So there is actually two lines in this research work. So the stereo vision group, they will use stereo vision to actually do the sensing. But for this LGBT, it got the laser scan, the laser beam that calculate the distance. Right, but both give you some very similar data. Okay, right. So for this, we actually can do a lot of things. We can use OpenCV, we can use YOLO using the deep learning. We can recognize object in real time, like we move, and then you can detect. And we can also use it to detect, for example, like human motions. Later on, I will show you a lot of examples using the deep learning. For example, like the open pose that can see all your skeletal movement. It can track your body movement. Or we also have, for example, like the facial one that can see the face, it find all the landmark, and then it try to detect what is your emotion. For example, are you happy or sad, or you are like bored, and so on. Right. So we have a lot of this kind of example later on that I can show you. Right. And for my student also, we've done some research work on this vision based on the illumination intensity and learning. We use the cycle gun, which is another regenerative machine learning techniques to see how human can actually recognize certain things in different lighting conditions. For example, you can understand this thing, okay, based on the color information. But when you close the window, everything becomes dark. You can still recognize this thing. So you recognize this thing not based on just the color information, but how the pattern of the color. Right. So when you change your light condition, for example, like I close everything and I shoot this with red light, then the whole thing looks very different or different color light, but you still can recognize this thing. Why? It's because like we understand in different conditions how the things change, how the appearance change. So we use this, we mimic how humans learn this and use the cycle gun thing to actually make the robot able to have this capability as well. Right. So this is one research that we have done. Okay, then autonomous navigation. This one I don't need to explain much, you know. Like from mobile robots, we can actually build a map. Then from the map, we can actually do what we call the AMCL, the adaptive multicolor localization. So from the localization, we can actually move the robot from one point to another point based on the localization from the map. Because you have the map information. And this one also is something very similar like human. You still remember when Apple introduced Google Map on your phone that connect to the GPS and you can use the map to move from one place to another place. I think it just happened in our lifetime, right? Or maybe it's already in your life ever since you are like a kid. I'm not sure. I'm not sure when, but I don't think it's that long ago. Right. So that technology is actually very similar like how we make the robot do it. So first we give the robot a map. Then the robot has some capability to localize itself according to the map. And then based on that, it actually can find from one point to another point based on the continuous localization. Because like when you use a map, it's the same thing. You remember, okay, so when you go to a new mall, you have no idea. Then you have you look at the map. What is the first thing you look at the map?
Where are your location?
Correct. Where are you, right? Right. Because you need to localize yourself. Once you localize, then you understand yourself with respect to the environment based on the map information. And from there, you can read. So it's the same thing. So that is exactly the behavior where I will show you how to do the SLAM and also the AMCL thing to do the autonomous navigation. Right, then we have manipulation. Okay, so this one, I don't need to explain much. I can really show you like you can actually move the robot to somewhere, grab something, and we combine that to say that we have the Roomba to actually clean the floor, right? By mopping or by like sucking the dust. Okay, but one of my students is actually building a robot try to pick up the toy on the floor. You know, like if you got kids at home, then somehow like they will like just throw all the toy your Lego pieces or whatever scattered around. The very narrow and very congested like living room. So one of my students is actually building a robot to actually collect those things and look at the parts and put in different boxes. For example, like pick up the Lego set into the Lego pieces, pick up the doll into another boxes and so on. And also if got trash, then you put into the trash can and so on. Right. So these are one of the mobile manipulation example that we think will be useful in service robot development. Okay. Then lastly, of course, the brain. So as I said, AI especially is very, very important for service robot because because when we build service robot, the important thing is the intelligence as compared to the efficiency in industrial robots. Because in industrial robot, the focus is always on productivity, automation, speed, and so on. But for service robot, it's the intelligence. Intelligence includes like the experience that we can see in the human, and then the capability to adapt to the changing environment and so on. So we have done a lot. For example, like we ask the robot to learn, and then we connect to because a lot of things we can do on the cloud now. Even later on, I'm going to show you like the speech is going to like infer the speech from using Google API, for example. So we use the Google big server farm to actually do the recognition for us, right? So now all the robot can connect to this one is also a Wi-Fi router that we can connect to the cloud, and then from there we can actually learn a lot of new knowledge that we don't know. Because like local processing and local knowledge is always limited. For example, I ask you to, for example, make a dish, bake a cake. What you do? You go to YouTube and search for the recipe, right? So that is how humans connect to the cloud and get new information. And the robot can do the same thing. And even the robot can do this process more efficient than human. Okay. Right. So this is one of my previous research that we actually make the robot learn from a lot of human. For example, if you play online multiplayer game, actually your gameplay is being recorded and use it to train the AI of all the minion things inside the game. So this is actually there is a lot of algorithm that we learn from human intelligence and put it on the robots. Okay. Right. Okay. So that's all for introduction. If you have any question, you can ask me anytime. Okay. Okay. So how to start building a service robot? Okay. So we started actually, particularly for myself, we started ever since the existing or the introduction of TurtleBot 2. So TurtleBot 2 introduced somewhere in 2012, if I'm not mistaken, the first version of TurtleBot 2. That time ROS just came out. ROS came out, I think, like 2010. And then we have the TurtleBot 2 as the learning platform. So starting from that time, I stick with TurtleBot 2 and I start to extend to build into a service robot. So we extend the TurtleBot 2 platform into a service robot. So, and over here you have 3 units of this. This is the Kabuki, which is the base of this. So in this workshop also, hopefully I can show you how you can make use of this to build up your service robot. Okay, so we always start with a lot of open source technology. So everything that I show you are open source. Okay, so you can actually copy and use it for your project without much worry. And you can download all this software for free. Right? Okay. So for this platform, we actually not just rely on the mobile base, but we extend a lot of things. For example, we have an arm, we have the human-robot interaction, we have extra vision, and also we have one LiDAR over here, you can see. So this one is to enhance the navigation purpose. Okay, so we extend that. We use different module and put it together. So for the specification, these are the things that for reference by quite old. This is quite old, but still good that we are still using today. For example, the visual perception, we have this. We are using previously we were using the Kinect, the very old Kinect, but now we are using the OBEC Astra. But we also have other things. For example, the Action, that one is already stock production. Kinect already stock production. Astra is currently their new version, or you can also use, for example, Intel wheelset and etc. And also I think OpenCV, they come out with its own stereo vision camera as well. Or I cannot remember the name, alright? Okay, so these are the things. And then for the arm, yeah, you can use sophisticated arm. Okay, you can use like, don't know, the elephant robots, or we got quite a lot. But over here, one thing that I want to stress is like the arm that we try to introduce in service robot is mostly we take those from Cobot. You know Cobot? COBOT, which is collaborative robot. So Cobot is a new generation of robotics arm that have the compliant capability. You know what's compliant? Compliant means if the arm hit you, you're not going to get hurt. It's something like your friend, like, yeah. So it will have the compliancy. Okay, so that is the special features of what we call the Cobot. Because before Cobot ever happened, actually there is a strict regulation that no human should enter the working envelope of an industrial robot. It needs to be fenced. Because if you got hit by the industrial arm, you're going to get hurt. So they actually have a regulation in the factory that no human should enter the working envelope of the arm. Okay. But over the year, technology have been, and that was also one of my PhD development. So we actually worked on that. And then eventually today, you have what we call the Cobot, which is the industrial arm that is safe to work with human in close proximity. So which means like even if you suddenly hit on the arm, it's fine. Okay, it already have the safety enough that to protect the human from this kind of collision accident. Right. So that one is more recommended if you put those kind of. But of course, for cost, this is not possible to put a Cobot. But that is actually ideally for service robot to have those kind of features. Right. Then the rest, yeah, you can think of yourself later on. Right. So the idea, how we build this robot is always we customize. So especially for open platform, we want you to learn how to customize because this design maybe is good for task A, but not good for task B. For example, in RoboCup, we have certain tasks that you need to pick up things from higher altitude. Okay, we've got certain tasks that require the robot to talk to different group of people, so that you can have, for example, like we have the omnidirectional microphone, the microphone array and so on. But got certain tasks you want the robot to talk to a specific person in a very noisy environment. And during that time, you want like a directional microphone and so on. And we have tasks also you need to pick up things from the floor instead of the high altitude location. So in open platform, we encourage you to redesign both hardware and software in order to optimize for the task. Okay, right. So and that is why I want you to learn beyond the design of it. And this robot is open, not just the software, but open in terms of the hardware as well. As you can see, everything you can actually unscrew and reassemble the whole thing in another form. Okay, but the building element is always this slide. Okay, so you have the human robot interaction part, the vision part, you have the mobile platform part, the arm, and also the intelligence. Right. Okay, so these are the resources that are available online that we work out based on what we have developed in RoboCup atHome community. So we put up, you can go to find our open courseware, our learning community, even we put up the source code reference. So a lot of examples that used in this workshop is actually taken from the GitHub. Okay, I'm going to show you this GitHub repo later on because you are going to use it for your workshop. And we have a lot of videos also, as you can see. For example, like the workshop today will be also one of the collection. Okay, right. The design example. So that example is the one that I'm going to introduce to you in this workshop. Okay, so we divide into two kind of workshops. So one is a hands-on workshop, is like this, so face-to-face. And then for my workshop, it's not about lecture. So I'm going to only do this for the first session. Later on, I'm going to tell you something and you're going to do. Right. So it is my way of teaching is always learner is the center of the teaching. So which means like I don't teach, but you learn. You understand the difference? Right? You learn and I guide you. So you have to, I will show you what to do and you learn from what you're doing. Okay, so the hands-on workshop is very important, and these are the components that we will use. You have the mobile platform, which is the Koboti is the mobile platform. The RGBD sensor, this sensor, you have the sensor over here. This is the RGBD sensor, right? Then you got the arm. Okay, this is the arm. This is the only one you have, but later on you can do your own. Speaker and microphone is available on your laptop, or you can use here. This one also got speaker and microphone, and your laptop speaker. You need a controller, right? And software, mainly we use open source Ubuntu, ROS, and a lot of open source software, for example, YOLO and other stuff, right? For online classroom, for example, like now you don't have the robots, okay, but at least you have the I/O. And even if you don't have the I/O, you still can do other things. For example, the mobile platform, for this one, you can use it the simulation version. We have the simulation model that I'm going to show you. Okay? When I show you how to do the navigation, I'm going to show you two versions. One is the actual hardware navigation. Another one is the software, which is you do in simulation. And I'm going to show you to compare these two. So actually, even if you work on the software simulator, the map that you build in the simulator can be used in real world if you have a one-to-one model. And even I can show you like the map that you build on the real world, you can put in and do it in the simulation. For example, like after you build a map, then you bring home, then you don't have your arena anymore, you don't have your robot anymore. Then you can still continue to work using your software, the simulation. Okay, so they are actually quite comparable to each other. But for RGB sensor, there's no way. If you don't have the sensor, basically you don't have the data, but we can still do a lot of things with your webcam. Okay, I'm going to show you the difference between the webcam and also this RGB sensor. Okay, and then ARM also we have the model for the speaker and phone, speaker and microphone. This one available on and the software are actually the same for the hands-on workshop and online classroom. In fact, we standardize so that any box that you plug in, you have everything that you need for the workshop, whether it's online or offline. Okay, so now I'm talking about the PC setup. So what is this PC setup means? Later on, you need to see how you want to develop the whole thing. Okay, are you going to like have a laptop, which is normally you are going to do that. Okay, your laptop is a Linux system, and that laptop is going to be on your robot. Okay, so that is the normal situation that you do. Okay, but sometimes that is not very convenient. Okay, because like when you are doing navigation, for example, then your laptop is moving, right? Then your keyboard is actually on that. Then you have a lot of problems, right? So usually we have a remote desktop, which is secondary, so that you can work with that, right? Okay, so we can do like remote desktop, for example, a team viewer, so that we can have the robot. So I have, for example, this robot, we have a NUC, which is a PC over here, and the screen, so that this thing works as a PC by itself, and then I can use another laptop to actually do remote control, so that we can see those things. And you need to set up for ROS, we need to set up the master and slave system and so on, right? So for the second one, can have the robot that run on a Linux PC, which this is the case. You have a Linux PC, and then for remote, it can be anything. Because if you are using the team viewer, it can be anything. It can be Windows, it can be even Mac. As long as you install the software, you can do the remote desktop. Okay. The third one, which basically is the best, the most ideal one, is you have the robot in Linux PC, and your remote is also a Linux PC. And why that is best is because like you can your ROS. I'm not sure how much you know about ROS, but ROS can work well in this distributed processing, so that you can actually have all the topics, all the data on the machine on your desktop as well. So it's easier for you to do visualization, especially when your robot is busy doing all the processing for the wheel. You don't want to like ask your robot to do the graphic rendering so that you can see your RVs with all the 3D data as well. You're going to ask another machine to do that. Okay, so that is when you have. So any of three of this arrangement you can do. Okay, this one of course is the most how to say flexible, but it's also harder to set up. The first one of course is the easiest, but usually I would recommend you to set up at least number 2. You have another one, which is you have a team viewer. Right. Okay. So I'm going to show you how to do this robot later. Okay. Okay, so for you who don't have this and don't have the I/O or whatever, but you still want to build your own, you have your Windows, so you can do, for example, like you can have Ubuntu 18.04 by doing a dual boot. Okay, but if you are not very familiar with computer system, be careful to set up dual system. Okay, there's a possibility like you might erase your Windows system. I have students and it happens every year. Okay, so I make sure like you don't save anything important in your Windows and make sure your Windows can be recovered. Okay, then only you can take the risk of setting up a dual boot. Okay, because every computer just has its own problem or its own setting. Okay, I even found out like I still remember because like last time before I used this I/O, which is now you instantly have the system. Before that, I need to set up dual boot for all my students. Last time, I have like 30 students in each class. Every semester, I spend almost 1 month to set up dual boot for everyone, and a lot of weird kind of motherboard that I fixed. Like I still remember got one motherboard. After a lot of research, we found that the manufacturer of the motherboard told us that you need to update the driver in order to install Linux. I never heard about that. And it is very risky to update BIOS. Maybe you never do that before, right? It's very, very risky to update BIOS because you might break the whole thing. Okay? Because when it breaks, you cannot do anything anymore unless you can open up the BIOS and then do which is none of the things that you can do with normal internet. Okay, right. So make sure that you know what you're doing if you are going to set up a dual boot system. Okay, but the safe one will be using a VirtualBox or VMware. Okay, but the problem with VirtualBox and VMware is first the speed, the resources will be like cut half, even more than half actually, because you need to run your Windows. Then on top of Windows you run Linux. Okay, that is the first question. Unless you have a very, very powerful machine, then it's okay. The second problem is the USB port, whatever that you connect outside. Okay, for example, like now VirtualBox and VMware, only recently they have the driver so that you can connect something USB 3 at the moment. Before this, it's just up to USB 2. For example, your Windows 10, if USB 2 is not ready to run. Okay, so for VirtualBox, it has two problems. One is a resources problem, another one is interface with external hardware, whether your sensor or whatever thing. Okay, so that is something that you need to expect if you want to set up this kind of system, right? Okay, right. Okay, and after you set up your Ubuntu, you need to set up your ROS, which is also very straightforward, but you need to be careful on the version. Okay, if you are using 18.04, you have to use melodic. Don't use other thing, because if you use other thing, it's going to be like a lot of problem with compatibility issue. Because that is what the ROS system already said, like 18.04 melodic, and then 20.04 is melodic. Alright, so currently we standardize with 18.04, please make sure you use melodic. And this link is very, 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 very important. Okay, if after this workshop you want to learn a lot about ROS, this tutorial you have to finish. Okay, at least up to this workshop, the basic one you should almost glance through all the things. Okay, when I start to learn ROS, which version? Start from G. Okay, that version. Now it's M, right? So the version that I learned is G. So because like G and then G, yep, G, H, I, J, K. After G is what? I, indigo, then kinetic, and so on, right? Okay. So when I learned ROS, the tutorial is actually very hard to read. But today, the tutorial is actually very easy to read. And also, other than the tutorial, you can find a lot of resources. You can even find videos to show you how to do a lot of ROS things. But always, I would recommend if you want to learn ROS, this is the resource that you definitely don't want to miss. Okay? So go through this. I'm not going to teach you or show you a lot about ROS. I only show you a small part, which is later on I'm going to spend 1 hour to show you the ROS basic, but that's all. Okay? People are learning ROS maybe 3 to half a year, 3 months to half a year. But I'm just want to show you very, very simple thing which is covered in 1 hour, which is enough for you to use it for the workshop. Okay? But anything extra, please learn by yourself. And the best part, and the best place to learn is this ROS tutorial. So remember this. Okay. And for the tutorial setup, especially if you want to use your Kabuki units. Okay. And actually, the tutorial software officially only support up to Indigo version, the version before Melodic. Right. But somehow, a lot of people because this is open source effort, so somehow we make it work with Melodic. So it still works. So you can refer to all these things and set up. So these are the links for your reference eventually if you want to work with this way. Okay. Okay. So I'm not sure how many of you know ROS? 1, 2, 3. Oh, okay. None of you? None of you know. Okay, so you listen this and remember. Later on, you refer back this. First is we follow the ROS tutorial and create the ROS workspace at this place. Okay, it can be in another place, but we standardize somewhere so that we can have a common place to talk about. But of course, later on in advanced stage, you can change your workspace. You can have multiple workspaces up to you. Okay, but as a beginner, we stick on this. We follow the ROS tutorial, so we use the Captain WS as your ROS workspace. And please remember this workspace because you are going to do everything inside here. Okay, right. Then this is to set up. Okay, don't worry about this. Okay, you don't need to do anything here. I just want to tell you this thing. Okay, you just remember about this. Then we are going to use this, as I said, the RoboCup and home education GitHub repository. So that is the repo. Learn ROS. Okay, so that repo is all the example, contains all the example that I'm going to show you in this workshop. And this one you can freely download for your own version of ROS as well to try out with the example that we open for the public. Okay, that one. Okay, if you're ever using MATLAB, okay, this one you can keep it. And if you are setting up your own system and when you download this, you compile, you have error, you can delete off the ARM folder and it should work after that. Okay, so I want to say it again, this is where all the examples that I show you in this workshop located. Okay, right. Right, so if you don't know ROS, I also think that you haven't used Git or GitHub, right? Anyone familiar with Git or GitHub? GitHub? Okay, so this is just some guide for the beginner. Alright, so if you have no idea what is Git, you just try out. Eventually, after you learn Git, this is the most basic thing that you are going to use. Alright, so this one is for your reference to learn Git. I encourage you to start learning how to use Git and GitHub. Okay, Git and GitHub, they are different, okay? I hope you know what is the difference. Okay, so I encourage you to learn how to use Git and use GitHub to actually manage your source code for your learning. Okay, and previously GitHub only allowed for free account only allowed open repo, but now they allow private repo as well. Okay, right. Okay, so the first assignment before I proceed, 1 hour, good. My timing is good now. Right. So the first thing is for you to have the I/O. For those who have I/O, you don't need to worry about this because you already have your Ubuntu, your ROS Melodic, your Turtlebot 2 package set up ready. For those without, okay, whether you want to use a boot or whether you want to use a VMware or whether you want to use a VirtualBox, try to find out a way so that you can have the environment. Okay, the fastest way should be in VMware or VirtualBox. Okay, it's up to you. VMware or VirtualBox, both is okay. It's whether which system you are more familiar with. Okay, so you need to set up a system, but because this is a 2 days, you remember this content is previously I used it for a 5-week course. So the student have plenty of time, like after the first class, they got like a week of time to set up this. So for this 2 days workshop, you don't have this time, but maybe you can do this later on. Okay, set up your ROS system so that you can work on it. And the fastest way, of course, and the simpler way is, of course, the VirtualBox or VMware, but it got the drawback that I mentioned before. Right? And then you also get familiar with GitHub, try to create an account, play with it. Don't worry, you are not going to break anything. Just create a free account and then learn how to do it. And you can learn, practice to upload your assignment, this class assignment, and upload there. I actually did that for my students. So every time when they want to submit their assignment, they send me their GitHub link. Okay, so that's the best way actually to submit the assignment. Okay, and do the ROS tutorial, at least for the beginner level. Right, okay, so with that, I have completed the first half of the first session. Any question? Any question? Okay, I'm going to do this so that later I can cut the video and put it accordingly. So that's why I have this sequence. Any question you want to ask? Anything up to this point that you are not clear? Okay, no? Yes.
Why I cannot use Neotic instead of Melodic on it?
Because-
version.
Because if you want to use Neotic, you have to set up your Ubuntu in 20.0. Okay, it's coupled with the Ubuntu version. So if you use 18, you use Melodic. If you use 20, you use Neotic.
So I cannot use
No, cannot. Yes.
newer version.
Yes. So you cannot use Neotic on 18. You will have a lot of issue. Okay, that is required by ROS system. Okay, you look at the website, it will tell you. Don't do that. Follow exactly the version that they recommend. Okay? Right. In fact, the Jupyter system actually going to upgrade this year to 20.04 with Neotic and ROS2. Okay, so if you are the beginner, I also want to explain a little bit about ROS2 because ROS1 is actually at the end of the support now. Okay, and the ROS community is actually encouraged everyone to shift to ROS2 now. Actually, they already asked us to shift to ROS2 like two years ago. Right, so now it's almost the end of ROS1, and after I think like another 2 years, ROS1 support will be ended. Okay, so actually we are moving to ROS2, but for this workshop, for simplicity, for beginner level, I would say ROS1 is easier to introduce to. Because ROS2, I need to explain a lot more things. And I think it's harder to use in some sense. And also the compatibility is not as good as ROS1 for a lot of old stuff. Because if you are still working on kernel board and all this old stuff, a lot of old stuff. And if you want to integrate with a lot of other system, commercial system, those things, they are not always using the latest software. Because the latest software always have one issue, compatibility issue and stability. For commercial software or commercial product, they always want very stable thing. So that's why today I still show you Ubuntu 18, this is actually already like old system. Okay, but it's stable for you to learn. So you learn this as a base, and I believe that after this you can upgrade yourself to ROS2 without a lot of problems. Because once you know ROS1, learning ROS2 is much easier. Okay, but I want to tell you that now ROS1 is actually at the end of the support area, support timing, and eventually we all need to move to ROS2, whether you like it or not. Okay, it's like if we are still using Windows 10, now everyone is using Windows 11, something like that. Then you might say, my system cannot support Windows 11, not meet the system requirement and so on. Well, that is the whole world like this. Not everyone having the same, like the latest machine and so on. So we need to learn both. Okay, the best way is you know both. Okay, I know ROS1 and I just written a book in ROS2. So I can do the comparison, and I still conduct workshop in ROS1 because I understand there is a value over there. Right? But I just want to remind you that eventually you need to move to ROS2. Okay? Right. Okay, so the first session done. I'm going to proceed to the next one. Okay, now it is the time. Assume all of you have the Ubuntu system now with the ROS setup. Nice. Assume, okay? Because we don't have the time for you to set up your Doboot and so on. So at least you can work with the I/O that I passed to you. So that is the reason why I passed you the I/O, so that you at least have one within 3 of you can work on them. Okay. Okay, so you will take turn to do all the things together with me. So, are you ready? Can I proceed with it? Okay, right. So let's start with this. So ROS basic. So I'm going to show you very quickly about ROS in 1 hour time, and you are going to be ROS. I mean, like you can actually develop with ROS like after this. Very, very ambitious statement, I would say. Yeah. Okay, so this is the second section of this service robot development. So we use ROS as our software framework. Okay, there's a lot of reason why we choose ROS as our system software basic. software framework. Okay, there are a lot of reasons that we do that. Okay, so what is ROS? ROS is called Robot Operating System, but ironically, it is not an operating system. Okay, even the ROS people say they are not operating system, but they put the name ROS, Robot Operating System. Okay, because of catchy and so on. Why? Because the operating system that you are running ROS is Ubuntu. It's a Linux system, and that is the operating system. Okay, so ROS is basically a software framework. I usually explain ROS as a software framework. Software framework. You understand what is the difference between a software and a software framework? Like a YOLO is a software framework. It's not a software. Because it's in a framework with a lot of software inside there. Okay, so ROS is a software framework that it coordinates with a lot of software. Okay, right. So that's why it's called software framework. And these are a few reasons why we choose ROS and why today I think I can confidently say about 80% of robotics researchers or scientists. I'm not talking about those people that use robot. Okay, a lot of people use robot without knowing what is running inside. But those people that develop robots, those people that use robot for research and development, about 80% and above, at least they will use ROS in some place. That's what I think. Right. So that is one of the very strong statistics to prove that why ROS is a very popular software framework that we use. Okay, there are a few reasons why. First, the plumbing. Actually, this is one of the very important reasons why ROS is very useful when you develop robots. Because when we develop, I'm not sure, have you developed any robots before this? Have you developed any robots? Can you name me a few? Like, what robot you have developed?
Line following.
Line following robots. Okay, so how you build the line following robot? Like, on what controller?
At Mega 32.
Okay, yeah, atMega 32. All right. So you write in assembly, or you write in basic, or you write in C.
C.
Okay, so you write in C, right? So this is one example, right? So you have your atMega, then you need to build your circuit board, right? Because atMega is a controller, right? Then you build your circuit board, then you have your sensor, your line follower, right?
Yes.
So you have a line sensor, and then you are going to have your wheel, right? So you have the motors, right? Then you are going to burn your source code into that atMega, right?
Upload this.
Okay, you upload, you bootload it. Okay, so you can see this is a very simple system, which you only do one thing. You only have one input and one output. Okay, or maybe like two sensors or two output. Okay, but it is very similar. You don't have like you don't have very asynchronous system. For example, like you have the light sensor with sound sensor, with temperature sensor, with a lot of different type sensor, and your output is not just the wheel, but a lot of other things. For example, like you are. So it's a very simple system. So all you need is basically one software, right? One software to interface with the electronics, and the same software can interface with the motors, right? Okay, what happens if now I take away your sensor and later, for example, that particular system. So it requires only one software. So it's not very complicated. It's only one software. So you can use one software and do it. And mostly before ROS, everyone do things in that way, which means you try to limit to make sure everything works with one software. For example, I write in C, everything interfaces with C. Okay, what happens if you buy a sensor, for example, an ultrasonic sensor? No, okay. Something more advanced. For example, you buy a LiDAR sensor. Okay. First, it says your interface have to be in TCP/IP, so you need to connect to a router, and then it gives you the software in, for example, not in C, but C++ is still good. Okay, but it says okay, you need to run in Java, for example, things like that. Right. So you need to figure out a way to interface the hardware and also the software. Then later on, you bought another motors. That maybe the motors you need to run with analog system. Okay, you need to give like the analog signal in order to change the speed, or do the control protocol. Then you have a motor driver. Then the motor driver have another set of driver and also the software to use to interface. Maybe you say, okay, you need to use MATLAB, for example. your atMega is not going to run MATLAB, right? So how are you going to do that? Right. So eventually, when you build robotic system, the problem is your system is getting more and more complex, and the software you are handling is more and more a lot. Okay, you do a lot. And the tendency or the possibility for all this software to have a common software is very, very low. Okay, very, very low. They will be like, okay, this one you're using C, this one you're using Python, this one you're using Java, etc., etc., etc. For example, suddenly you want to interface with a web system, for example, then it's using Java, right? Or even JavaScript or whatever thing. Then, for example, you have your atMega. Then you want to interface with a PC system, for example, or you want to interface with another controller, for example. If you want to interface with, for example, another microcomputer, that is okay. But if you want to interface, for example, a PLC, for example, or another machine. So these are all the problems that makes robotics development very complicated, time-consuming, because you need to spend a lot of time not developing your robot, but developing software so that they can talk to each other. Okay, so before ROS, actually when I build robot, I spend most of the time doing all this thing. Okay, and it is very, very tiring and it's not helping in my development because my development is not about all this. It's about after I put everything together, I want to do a new application. But I don't have time to spend on my application up before I solve all these low-level issues. Okay, so ROS come in, and first they try to solve this problem. No matter what hardware or whatever process, whatever thing, eventually after you plug everything into ROS, you just need to write something that ROS can understand, and ROS will try to coordinate the rest. And eventually, because ROS is so big, that nowadays, the manufacturer actually come with a ROS package for its own product. For example, you buy a sensor, then you say, okay, I'm using ROS. They say, yes, we have a ROS package. Then you just put the ROS package in, done. You don't need to care how the software actually interfaces with the hardware. You don't need to care. You just in ROS send a topic and it works. That is the beauty. Alright, that's the beauty. So the process management, the inter-process communication, the device driver, that is very, very important. Okay, maybe you haven't reached this level yet, but if you build robot system that is more and more advanced, not on the machine level, not on the control level, but more advanced, for example, the PC level. PC level, we are not talking about microcontroller anymore, right? We are talking about TCP/IP, sending your data in data stream format and so on. You are not going to send one bit, one byte and so on anymore. You are sending something. So this is what I call, we focus on the high level development and focus on the application development. All the low level lets all the software to take care of all. Okay, so the robot that you are going to build with this service robot, we are handling with PC system. Okay, so anything that works on PC system, it works. Okay, understand? Right. Okay. So that is the plumbing. Then the next thing is tool. For example, when I still remember when I built a robot last time, then my supervisor said, can you build a simulator to simulate your system and design before you build the hardware? It is actually building another project by itself. Because a lot of people can graduate with the simulator, right? Right. So it is actually very, very hard for us to even build a simulator before you simulate the result and eventually come up with the best design that you build hardware. Okay? Although ideally it should work in that way. Before you start anything, you write your equation, you do your modeling, then you write a software to simulate the equation and everything okay, look nice. Then I start to build the robots. But how many of you actually go through this? No, you straight away you take the hardware you build and you see whether it works or fail. Then you design, then you change from there. Then after you do a lot of iteration, then only you say, okay, I need optimization. Then only you start to think about simulation. That is, in practice, always that way. But ideally, you should do your simulation first. Let's follow the books. Alright? So in ROS, it actually provides you a simulation environment ready, as long as you build a model in ROS. So that makes us, every time you build robots, if you do properly modeling in ROS, you basically have the simulation model. And you can simulate with the simulation tool in ROS. Okay, and then the visualization. This is also very nice. Later I'll show you like how the visualization of the tools. If I ask you a question, like I don't know how big the data streams that you handle. For example, your line follower, you're going to talk about like integer, bit, and all those things, right? Have you ever used a sensor that gives you, for example, a video stream? Or a 6 degree of freedom sensor, for example, like you have an accelerometer that gives you a lot. For example, this RGBD. Okay, RGBD. RGB give you R, G, and RGB tree value of 0 to 255, right? And then D is basically X, Y, Z. Okay, so in one pixel, you have RGB X, Y, Z. And you are going to have a big array of, depends on what is the resolution. And that one, it depends on how many frames per second. For example, you have 10 frames per second. Can you imagine how big is the data? And you're going to slow that. Okay, so now the next question is, can you plot that thing and show me in a 3D space? Okay, a simple question. Can you plot a graph that is 3D? Usually you need to plot a graph that is 3D. For example, you have 3 axes. What tools you use? Sorry? MATLAB, right? Okay, MATLAB is not 3D, right? Okay, I'm talking about an easy one. So last time I always ask why Microsoft Excel don't have this feature. I just cannot bring, maybe can, I don't know, any expert in Microsoft Excel. Because I do experiment everything with Excel, right? The data sheet that I already. So in Microsoft Excel, I was like thinking, can I plot a 3D graph using Excel? Cannot, right? Anyone know how to do it? Okay, the best option that I actually learned is GNU plot. Maybe you never heard about it. Okay, GNU plot is the best option other than MATLAB. Okay, I understand MATLAB can do that. But MATLAB, you need to fork out a lot of, like, to pay the software in order to do that. And it is also not easy, like, you need to port all your data into MATLAB and do those things. And then after that, you output the thing back to your system and so on. You cannot do that in real time. Okay, so the best thing, if you run everything in Linux system, you can use the GNU plot to actually plot you a 3D graph that you can drag and drop and so on. Okay, so there is actually no option, like easily option, even just to plot a 3D graph. What happened to you have a lot of sensor data, a lot of very like big data that you want to show it in a 3D plotting. So in ROS, it actually have the RViz to show you this thing. Later, I'm going to show you the data from this, okay, so that you can visualize it. Then the GUI, the data logging. Data logging, maybe you will know when you are doing experiment. You haven't done your experiment, for example, like you need to track your sensor data throughout the whole journey, and then you need to like do your diagnostics on the data and so on. So those things automatically is be taken care in ROS, so that is one of the advantages. Okay, right, fine. Okay, maybe that one you don't really like close to what your implement needs. But the next one, I definitely think that you need. For example, capability. For example, I still remember when I built this robot, I actually have no idea how SLAM works. I don't know how to do navigation. Okay, but I need to do navigation so that my robot can do things in the competition or in the application of service robot. So I just use the TurtleBot navigation package, put in, run the example. I have the map and I can pinpoint point A, point B, and the robot does it. Everything happened magically without me knowing actually how it works. And that is what the capability that bring in ROS. So I'm going to show you a lot of techniques in these 2 days. You are not going to know what is actually the bottom calculation, but at least you can learn how to use it. Eventually, robotic system will go until a very complex level that all the robotics designer or developer is not going to understand everything. Okay, I still remember when I presented this to one of the professors like last time. They said, I'm bypassing a lot of things. But actually, it's not bypassing because like robotics system is getting more and more complex, as it is not possible that every time you want to build a robot, you start building everything from scratch. It's the same like you want to write a software, Are you starting building computer? None of you start with building computer, then only you write the software, right? None of you do that. Right? You don't even know like how the processor works, how the hard disk works. It doesn't matter. We know it works. Right? What important is you focus on. So ROS actually bring in a lot of all this control, planning, perception mapping, all this technology to us, but it actually make not possible for you to understand everything. Okay? You may be able to understand everything, but you also cannot build everything from scratch. Okay? It makes no sense that I'm going to teach you how to write SLAM from scratch. Unless this is a course to learn about mobile robots, then it's possible. Okay? So ROS gives us the capability that we can do a lot of advanced things that is done by other open source community, but what important thing is you learn how to use them first. Okay? So my approach is we do the top-down thing. We set what we want to solve, and then we choose which tools that we can use, we make it work, then we optimize. When you optimize, then you learn the basics. Okay, you go down and learn. For example, like you want to update, for example, my student, once they know the navigation, then they start to think, okay, I want to make the navigation more optimized in this situation. So how to change the behavior? Then they start to learn like what is the navigation package is all about. What are all those parameters, how to deal with parameters and so on. Then even go down to what is the algorithm. Can I change the object avoider algorithm? So that is a top-down level. It's very different from the bottom-up. Traditional university learning, we always go from bottom-up. We learn all the basics, then eventually you can do the things. But over here, I'm going to show you another way of learning, which is we are going to do the top-down. Okay? So this capability is very, very important. You are going to do a lot of things without actually knowing how it works. It doesn't matter. You can always do it later. Important thing is whatever tools that you use is open source and you can actually see what is actually running. Okay, so that is important. Then lastly, of course, the ecosystem. Now, any problem that you face in ROS, you just go to internet, search on it, you can find a lot of answers. Okay, there's no problem because like a lot of people use it. But that is also a problem because you can find a lot of wrong answers. Okay, so you need to have enough experience to know which one is the correct one. Okay, and that is your journey of learning. Okay, there's no way to tackle that. But at least we have a lot of documentation, tutorials to help you on those. For example, like now you want to use a system that is unknown, basically you are unknown. So this is basically the reason why we use ROS. Okay? Right, so I'm going to skip all this. Important thing is ministry and open source. Okay? Okay, let's start. So for ROS, now I'm talking about ROS 1, okay? ROS 1. The important concept is to run ROS, it needs to run the ROS master first. Okay, it needs to be always at the background. And the ROS master, if without running, you can run it manually by typing ROS call on the terminal. Okay, you can run it. And why we need this ROS call is because that is basically the backbone of ROS. So when you run ROS master, it will start the ROS system and it will handle all the things for you. You don't need to type anything first. Later you can type. Now listen. So this slide is very, very, very important. That if you don't understand this slide, you are going to have a lot of question mark later on. Okay, ROS system is very different from. For example, I use back the live follower example. So we have an ArcMega, we have a live sensor, we have a motor. Okay, so this is a system. So when you write a source code, you write only one C file, right? You put on a emulator and everything. Okay, so this is a centralized control. Okay, this is a centralized control. The problem with this centralized control is anything you want to change, you need to change everything. There's nothing in this source code can be reused for other applications without any modification. If you change the sensor, you change the whatever thing, you need to change the code. There's no way you can reuse part of the code. Okay, maybe you can cut and paste some of the line, but you cannot run it. I mean, like you cannot reuse a lot of things. Okay, so because it is a centralized, so anything changes in the system, you're going to change the whole. Okay, so now let's think again. This live follower example, but I write it in a decentralized method. Okay, so which means I write 3 codes instead of 1 piece of code. Okay, how I write? For example, the first code I write is to read the sensor value. Okay, so I got something like sensor.c, for example. I run the sensor.c, it's going to read the sensor value, and then it's going to send out the sensor value to another thing. Okay, so this is one piece. Then the center one, I'm going to write, for example, the calculation of controller.c, for example. This code is going to read the sensor value from code number 1, which is sensor.c, and then it's going to do the processing and tell the decision to another piece of code. Okay, so the controller.c, the function is only the logic. If the sensor is high, turn left. If the sensor is low, turn right, for example. Then the third piece of code, the third piece of code will read the data from the controller.c. Okay, and then if turn left, okay, then it will interface with the driver and turn the motor to the left. If it read is high low, then it will turn to the left or right, and so on. Okay. Then you will ask me why I want to make life so hard that one piece of code can settle everything, but I write in 3 code. Can you understand the 1 piece of code and 3 pieces of code example? Can you understand these two? Okay, so now I tell you what is the benefit if you write the code in these 3 pieces. Okay, first, if I want to introduce new sensor, or 2 sensor, or 3 sensor, or 4 sensor, I just duplicate the sensor.c and change the parameter. And it works for any sensor. Okay, for example, I want to change sensor A to sensor B. My controller and my motor, I don't need to change anything. I just change the sensor part. Yes.
How is that different to having code as different functions and it's a single program?
You still need to change the code.
Still need to change.
Right. Now my ultimate thing is if I have eventually a very complex system, I want my source code to be reusable as possible. Because I don't want, I make a small change, I need to change everything.
Yeah.
Then it becomes very complex, right? So I just want to make sure that I do the distributed way so that I can reuse a lot of things. For example, just like I said, I change the sensor or I add in new sensor, my controller code and my motor driver code still the same. Still the same. I can reuse it. Okay. And then for the motors, I can also do the same thing, right? If I change to another driver, I change another motor, my controller and my sensor still the same. So I don't need to change that. So I can reuse it. And I can have multiple to multiple. Okay. You might say, okay, if I write 1 piece of code, I don't need to send the data from one to another. Because sending the data from one to another is very, maybe you say like it's very troublesome. Because, for example, I need to write the socket, I need to do the handshake and all those things. Right? But if every time you want to send a message, you need to define what is the receiver, then when you change the receiver, you need to change this code as well. So, reason why now we try to explain this ROS system. Okay, so now you try to imagine just now the line follow, the 3 code become the node like this. So I have node number 1 is the sensor, node number 2 is the controller, node number 3 is the motor. Okay, and then ROS is connecting with all the things, right? Okay, so the ROS concept of building is always using this node. And the node is the smallest unit to run a single function, for example. Okay, so it's like this. And then the ROS master will coordinate all the different nodes, right? So to run a node, we use, that's how it's ROS call, right? Okay, so now it's ROS run. Okay, if you want to run a node, it's ROS run. The package name and the node name. Okay, the node name is the node name, right? Package is a concept that it will, it will organize a series of nodes that having the same function. For example, a speech recognition package. Under the speech recognition package, you've got a node that take the sound from the microphone, and then another node that take the sound and send it somewhere to do some processing, and another node that tell you what is the value. Okay, so that is the package. So the format of running a node is always ROS run package name with node name. Okay, remember this format. So next time when you look at some example, you know this is the package name. This is the node name because this is convention. Okay, right. Then you can use this node ROS node list to actually list down how many nodes currently running in the background. Okay, and you can use the info to actually look at the info. Okay, later we will have an exercise to do this. Don't really worry. Just follow this first. Okay, now come to the topic. Okay, so now you have the three nodes, which is nice. But why or how to make them talk to each other? Okay, how to make the node talk to each other? Because that is very important to make the node talk to each other to complete your program. Okay, but here is another very important concept. So just now the first very important concept is distributed. Okay, you are going to design your program in smaller nodes and the nodes are going to work together. Okay, so that is one very important concept of ROS. The second very important concept of ROS is how they communicate with each other. Okay, so now for example you have node 1 and node 2, right? So how ROS communicate is by not passing some value from node 1 to node 2. It's not written in that way. Not written. It is going to separate the communication into two parts. So the first part is the first node is going to publish the data to a certain topic. Okay? Regardless who is the receiver. Okay, so that is different. When you want to pass a message from A to B, you need to define B. Okay, so I write, like for example, I pass a message from myself to this person. Then only it established. Okay, but what happened is I want to pass this message to C. Then I need to rewrite this again. Okay, then I need to pass to D and so on. I need to rewrite this again. So this is not good. I want to reuse this part. So regardless who is the recipient, I don't care. I pass this message to a topic called sensor data or sensor value. Okay? Right, so I create a topic. So you have a topic over here. And the first node is going to publish the sensor value to the topic or whatever data that you want to pass. Okay? And this one is a complete operation. So I can define this thing without actually knowing who is the recipient. And the reason why I do this is so that this thing can be reduced. For example, I don't want to pass to node 2, I want to pass to node 3, node 4, node 5. I don't need to change any of this part. Because how to receive this is changing of node 2 so that node 2 will subscribe to this topic. So when you subscribe to this topic, you will take the value from the topic and put it in a node. So I divide the sending and receive to publish and subscribe. And I separate this into publish subscribe so that it can be independent from each other. Understand the concept? Okay, so this is how ROS node communicate with each other. Okay, and this is what we call the publish subscribe method. In ROS, we actually have 4 ways of communication, but in this workshop, you only know this one is enough. Basically, you are 80 to 90% of your development after this will be included. Okay, you don't need to care about. Maybe you need to use a bit about service, but at this point, at least you can ignore it. Okay, you just focus on the difference. Once you are familiar with this, then you can learn the rest. Okay, so publish subscribe. So now, any question about it? You clear with it?
So the topic is not exclusive for node. Let's say I'm doing node 1 and node 2. So to this topic, I can subscribe like multiple nodes to this topic, right?
This topic, once you created, you'll be governed by the master. So anyone can go to this topic and anyone can subscribe to this one. Anyone. Once the topic is established, anyone can push the data in and anyone can subscribe the data from it. Anyone.
And this publishing process and subscribing process is totally separated.
Yes, and it can be asynchronized. I mean, like there is how to say, there is ROS will take care of the synchronization. Okay, so for example, like suddenly your node 2 failed, but your data still there, still flowing. So you can quickly like node 3 come in and take over the job, it's okay. Or somehow like you want to add more node in node 2, node 3 and subscribe to the same topic, it's okay. You want to create a new application that listen to the topic, it's okay. So you no need to change anything that is already running. You just need to add. Okay, because the reason why ROS create in this way is so that the reproducible of your code is very, very high. It always standardizes everything so that things that already working, you don't need to change. You just change the parameter of how you use it. But the source code is that. Okay. The reason why this is very, very important because in ROS, a lot of things, I can tell you for sure, not only these 2 days, maybe like the coming half a year to 1 year, all you do is to reuse other people's code to build your application. Okay? I think it's very, very how to say, you're not going to write a new code for a new hardware that soon. You are going to do that much later. All you're going to do for development is you are going to learn how to use other people's code, assemble them together in the logic that you want to create the application. And that is you are going to do. So that's why learning this is very important because your job eventually is assembling different nodes together to achieve certain objectives. Because you are going to use a lot of sensor nodes, which these sensor nodes are created by the manufacturer. For example, I want to use this sensor. You are not going to learn how to pick the data from the raw data, do the processing, and put the data in a meaningful form, and then only use it. This part is going to be done by the manufacturer. For example, your line follower, you are taking raw sensor data, maybe it's in analog. Then after that, you need to use the analog, use a low pass filter, whatever filter, to compensate the noise and then pick up what is high and low, right? You are going to set the threshold and so on. But for this kind of sensor, not possible for you to do all this low-level thing. Okay? So the manufacturer is going to do all this job for you, and what they do is they put all the meaningful data into topics. What you do is you write a piece of node, subscribe the topic, and do something like that. Understand? So why this is important? Because you cannot expect the manufacturer to write a code that target to your application because they don't know who is going to use that. So that's why this architecture enable this kind of concept of development. Okay, any more questions? I can tell you, these things are quite new, I would say, from your robotics development. So that's why I will spend time on this very important concept, because if you are weak in this concept, eventually you will lose. You will don't understand why ROS in this way. But if you understand this, everything will look similar to it. Okay, any more questions? No? Okay, so let's go. So this is also very important command that I always use. ROS topic list. This one is for you to print out all the topic that's currently available in the environment so that you know what is currently active. Right? Okay, and then you can echo. Echo is to print out the content of certain topic. Print out the content. And then info is to check the characteristic of the topic. Later I'll show you an example. Right, then messages. Okay, so now we understand the concept. Right. So what this topic can contain, what kind of messages, we call messages, which is what kind of data can be flowed in this topic. Right? So when you do in C, for example, you say, okay, integer, variable, something, then you pass the variable, right? Okay, so you know the data type and so on. But now we are not, so this one is the dot message topic is defined in this form. So this topic can be as simple as, for example, a few integers, but can be as complex as, for example, this data set. Okay, so I show you some example, for example, like in this point message. Okay, so this is the dot message means the data type of a particular topic. Okay, so for example, this point dot message, the point is the tree float number. Okay, then you have, for example, the image type of topic, image. All right, you can have something like this. So what is this? Standard message header. So it got a header. Header means the meta info of a particular data. It's like a data structure. You got, for example, frame number 1, so you got a sequence number and so on. So you got like, for example, sequence number, the timestamp, the frame ID, and so on. Because the data is so complex that, for example, in your camera, you got different frames. So you need to know like which frame, what is the current frame, what is the frame ID. And these are the information that is appear in the header, not inside the pictures. Right? So this is the thing. So it can be like, for example, the height, the width, the blah blah blah, and so on. And also your data, which is in the matrix. So this is like an image, like one piece of image. And when you have this piece of image, and for example, over here, this is actually a post stem message, which is like your post. Like you got a lot of join, then you got a lot of XYZ. The quaternion and the point position, the XYZ, and the quaternion. The quaternion means the orientation. So it can be a lot of things. And this one, you can use this point message into this. Okay, so it can get very complex. Okay, but you don't need to care a lot about the detail here. You just need to remember that there's a way to describe the data type of the data format inside a topic. It's just like you explain when you write a C or whatever, you need to initialize, right? If you need to initialize the data structure, you know what I mean? Wait, how good is the programming? Any of you don't know programming here? Okay, what programming language you know? C, Python, you know. And then you know all these things. No problem, okay. I just was afraid that you actually don't know what is data structure and everything, then the explanation can be different. Okay, right. So you can see this, the definition of a certain topic. Every time when you want to create a topic, you need to define what data structure or what data type you use. That is written in the .msg part. Alright, so for example here. So this topic can be as complex as very like multi-dimensional data or just a few integers. Right? But the way how you subscribe and publish are the same. So that make life simpler. For example, you want to write in C code to handle an image stream and to handle an integer. Are they the same? Different, right? You need to do a lot of a lot of code just to make sure that it runs smoothly. But over here, no matter what kind of messages, the way how you publish and the way how you subscribe, they are identical. So that makes things very simple for you. So whether you subscribe to this sensor or this sensor or this sensor, they are the same. The way of subscribing is the same. Okay, right. So that makes life very simple. So you can use the type to see what is the type. Type means what kind of the thing, and so on. And this one, cross topic publish, is actually to manually feed in data into a topic without using a node. You can manually feed in. So as I said just now, once the topic exists, anyone can feed data in and anyone can read data from it. It doesn't necessarily need to come from a node. It can be from a terminal as well. Okay. Okay. Right. So now let's do exercise. Okay. In normal practice, I will show you the example, but I think now you should be able to follow. So first, there is a black color box icon there. That is the terminal. So for Linux system, when we want to run something, we use the terminal. Okay. So the terminal is a bash shell, is a shell. So you can type in certain command to execute certain function. Okay. So once you type in ROS call, you enter, you will see something like this. Okay. ROS call. Right. So over here, there are a few things that maybe you want to notice. First, you can see the distro and the version. Okay, so the distro should be melodic. Okay, and the version, this one is correct. And then you can see a ROS master URL. Okay, so what is this ROS master URL? This is also a very important thing. Is where is your ROS master? Okay, the difference between ROS 1 and ROS 2 is ROS1 have a ROS master, it have a core. So for ROS1, it is actually not totally distributed. It still have a core. It still have a master. So when is the master? It's written here. So Jupyter Robot basically is the machine. And this is the port number. Okay, by default it's 11311, but you can change this if you know what to do. So this indicates where is your ROS core. Okay, master, you are. Okay, but it doesn't matter, you don't need to change anything, you just go back to it. Right? So once you have the ROS core, right, okay, so now you still remember this format? ROS run, package name, node name, right? I say it again. ROS run is the command to run a node, right? Okay, listen to me first before you type in anything, so that you don't miss anything that I say, right? Okay, so ROS run is the command to run a node. What comes after ROS run? That's how I said package name. So now I am running a node from a package called rosctp_tutorial. And this package is already exists after you install ROS. Okay? Alright, so it already exists, it's already there. Okay, somewhere in the ROS directory, the path. Then inside this package there is a node called Poker. There's a node. So Poker is a node. Right? So if you do this, enter. Remember, when you want to run it, you make sure your core is running and you open another terminal. Okay. Every time when you key in a command and it don't give you back the prompt, which means it's running. You remember the prompt? The prompt is like something with the $sign, double dot, for you to type something. If you run, for example, you run ROS core, you see something like this, and this stop here, it don't give you it don't return you the prompt, right? This means this terminal is currently running something. Okay, so when you have a terminal that is running something, you should not type anymore. Okay, if you want to type a new command, open another, either a tab or Windows. Alright, okay, so this one you need to keep it running because it needs to run in the background in order for your process to work. Right, so you open another new terminal, you type in ROS run, okay, you specify the package that you want to use, and then the node you want to use after. And then you can see something like this, hello world 0123 and so on. Is everything okay? Yes.
Just now I'm interested maybe first I would like to increase my license. If you turn the way, I don't know how to access.
I have no idea what it is.
It's like Jupyter Robot is
Oh,
I just know how to access.
how you interpret it?
I just want control and then F5.
Okay, log in, you put Mustafa, password is also Mustafa. Oh, how come you are in the this thing? You just type exit. Exit. Oh, how do you run it in the system?
Because just now I'm just trying to.
I don't know, but it seems like you run into the bash command. So it's subscribe. I don't know where you know. Is there something?
I know. It's
because I don't know how you actually activate the command prompt. Okay. So let me explain what is actually happening when you run the node. Okay, so now you have a node. Okay, so now what I want you to do is let the two windows running. You open up a new terminal and then you use ROS node list and you see what are the currently node that is available.
now it's
Right. So if you list down the node that's currently available, you can see one is slash ROS out, another one is slash Talker. Right, apparently like the slash is like the node. So ROS out, basically after you have called the ROS call, you have the ROS out. Okay, so that is the system one, you don't need to care about that. But what I want you to notice is after you run the Talker, you actually have a new node called Talker. Okay, right. And then you can use the info Talker to check the parameters or the meta information of the particular node, which is over here. One thing that you want to take notice is it actually have the info for a particular topic. It always tell you who is the publication and who is what is the publication status and what is the subscription status. So publication status means someone is actually pushing out something to a topic, to the topic, for example, this topic, alright? So the publication is, the Talker is, okay, what is the Talker? Talker is a node, right? So if you read the info of the Talker, you can see the Talker is actually published in something, but subscribe to nothing. Okay, over here. So this is how you read this. So for the ROS out, as I said, it's system thing, you don't need to care. Right. But one important thing is, other than the ROS out, the system thing, it actually has something called slash chapter. And then behind that, this is the data type, the message type. Okay, so you have a chapter, which is this Talker is actually published to a topic called chapter, having the data type or the message type of standard message string. Okay, that is how you read or to understand this. You get it? Up to this point, anyone lost? Anyone don't understand what I'm saying?
So the chapter is the topic.
Yes. Okay, if you want to look at the chapter, you want to confirm, you can use raw topic info and chapter numbers to confirm, and then you can see something like this. And it will tell you that it will say it is actually published by, or the publisher of this is actually the Talker, and the Talker is located at this. Right, and then currently there's no subscriber to this topic yet. Okay, you understand what I mean? These are very, very important information that later on you will use a lot to analyze the topic, because you are going to use the topic for your application. Okay, you got me? Okay, you got. Okay, no. So now you can use type, you can use echo, and you can use the this hertz. So these are under the ROS topic command. So these are the command related to the topic. Okay. So the type, the echo, the hertz. Basically, the type is to show you what is the data type, the message type. Okay. And then the echo is to print out the content of the data, right? Which is hello something, hello world something. And the hertz is basically to estimate what is the publishing rate, how fast the rate of the publishing. And apparently, like when you look here, it's almost 10, right? 10 hertz. Okay, right. So this one you can test it later, it doesn't matter, right? Okay, right. Let's go to the next one. Okay, so now you are happy with the first node and the topic. Okay, now make sure you don't close anything. Make it run. Open another new terminal and run a new node called ROS run. Again, you can see it's in the same package. It's in the same package, and this time I have another new node called listen. Okay, open another new terminal and run the listener. Yep. Okay, then you can see it lists down like I heard something, and then you put this one side by side with the Talker. You can see like every time the Talker publish a hello world something, the listener will get the same data, the same message. So which means someone is publishing, someone is listening. Right? Then you can analyze again. So you run the list again. You can see this time you have not only the Talker, but you have the listener, you know. and you can check the info of the chapter, which now the chapter is being published by the talker and being subscribed by the listener. Okay. Yes, when every time when something is running, don't close it, open up a new terminal. Is everything okay? Okay. And this is the tool that is very useful for what is actually happening when you, for example, like you have a new sensor and you try to run the package and you try to learn how to use the sensor. These are the things that will be useful for you to analyze the topic that is generated by the new package, for example. Then you can learn how to use it. Okay. Right. So now what I want you to do, listen carefully. Go to the windows that run the talker node. You do Control C. Control C means to terminate the operation, stop the operation. Okay. So now what I want you to stop the talker node, and immediately you can observe the listener node also stop because it no longer listen or it no longer receive any data from the topic anymore. Right. But the listener topic still running. Okay, because you only stop the talker node. Okay, to check if your listener is still running, you can manually publish a message into the topic. Like this, Ross topic publish, and you want to say, okay, I want to publish to the chapter topic, and the message tag is this one, and you can insert your data inside it. You can write your name or whatever here, and you can observe that in your listener, whatever that you type in there will appear.
After I Control C the talker.
Yes. So this is just want to show you that anyone can actually publish to a topic as long as the topic exists. And the listener, as long as you don't Control C the listener, it is keep on listening. Right? Okay, is everything okay? Okay, you only stop the talker, you don't stop the listener, okay? Is everything okay? Can you see your old data in the listener? Okay, is it okay? Right, so if this is okay, so basically you have completed the exercise for publish subscribe. Okay, but that is the first half. Okay, later will come the second half. Right. Okay, so everyone have any question or anything that you don't understand up to this point? Everything okay?
The last one, it's publishing only once.
Yes, because you only type once. You can publish like
It's not like the Hello World, the
because the
simple
hello
one.
world got a loop inside it. Yeah. So it actually basically it publish in the loop. But for this one, you only publish one. Okay, you only send once. Right, is everything okay? Can I proceed? Okay. Right, so I will proceed. Okay, so I want to show you something. Okay, so you might want to take a break, listen to me. I will tell you a few concepts before I show you the source code of how to write the subscriber. How to write the Docker and listener. Right. So now you realize that when you want to run some application, maybe you need to run a lot of nodes. Okay, you need to run a lot of nodes, like the sensor node, the controller node, the motor nodes, and so on. So in order to run a lot of nodes together, you can use a launch file. Okay, but this one is for your concept, for you to know about this launch file. You're not going to write any launch file until later stage. Okay, just want to tell you what is a launch file. A launch file, you can run a launch file by using ROS launch, right? And then ideally it's supposed to be having a package name, right? So normally we will use the convention ROS launch, package name, and then the launch file, right? So the same format, right? And how to write a launch file? It is an XML format, and later on you will need to run a lot of launch file, but at this point you're not going to write any launch file at the moment. Okay, you don't need to write any launch file. I just introduced this so that you know what is ROS launch and what is a launch file. A launch file is basically a file in XML format that indicate what node to launch. For example, like you want to run like multiple nodes. Okay, you can use a launch file to run multiple nodes. That's all. Okay, and in order to see what node is currently running or what node is will be run, if you run the launch file, you just need to open up to see the content, then you understand. The format is something like this. So the format is something like this. For example, just now you run a Docker listener, right? So you can write in a launch file in this sense, like the name of the node is called listener or the Docker, and is under the package of ROS CPP tutorial. Okay? And then the type is basically the node name. Yes. And then the output string means whatever that is output into from the node, you will display on the screen. Okay, so this is how. So if you want to combine the Docker and listener into a launch file, this is how you write. Okay, right. But this is just to introduce the concept. You no need to write any launch file. You just need to learn how to run and how to look at what are the nodes inside the launch file. Okay, and also in a launch file, we can specify certain argument when you want to run something. This one also you are going to use it later on, and you are not going to use it at this point. Okay. So this is how to say the convenient tools for you to launch a lot of nodes with a specific argument, a specific set of argument, one shot. Right. So that is the purpose of launch file. Right. And other things. So this one you can do later, right? Okay, then the gazebo simulator. So this is also one of the component in ROS. We can use this. You can use this to check your gazebo if it is already installed. When fresh install ROS, if you fresh install, maybe your gazebo is not the latest one. You maybe need to update. But anyway, you can check if you're having the gazebo in your installation. But I'll come back to this after this. Okay, right. So with that, I have introduced the very, very basic of ROS that you need to know for this workshop. Okay, but there are actually a lot more concepts that you need to learn. For example, like the package structure, the C++ library, which is the ROS CPU. Because after this, I'm going to show you the Python way of writing ROS. Okay, right, and then I'll be TF. So anything that I've listed down here is the concept that you can learn from the ROS tutorial that I mentioned just now. Okay, so these are the concepts that you should learn if you eventually want to know more about ROS. Okay, and just now I also said that there are actually many types of communication way between the nodes. So publish subscribe is just the first way. You have the services, you have the parameter server, you have the action. Okay, the action is actually quite complex to explain as its point of view. So just keep the first focus to learn the publish subscribe first, then later on you can learn other types of communication. Okay, so today focus on the publish subscribe and make sure you understand it fully, right? Right, okay, so now this is, I will say, the most important part for you to learn, that you are going to use this a lot in the rest of this 2 days. Okay, so which is browse, publisher, and subscriber. So just now you have run the example, right? So you have seen the effect of the publisher and the subscriber from the Docker and listener node, right? Okay, so now I'm going to show you how to write or how to create these 2 nodes. Okay, so in order to create these 2 nodes, and I'm going to show you how to create using Python. Okay, not C++, but Python. So first, every time when you want to create a new application, you create a new package. Okay, and the way how to create a package is, first you can check, this is a reference. You can go to that page in the ROS tutorial to show you how to create a workspace. But basically, this is the way how to create. Okay, so maybe you are not very familiar with the bash command. So mkdir is make directory. Dash p is basically to create like multiple layer, right? Okay, this how to say, this is a wave symbol. This wave symbol means from home. Okay, in Linux you always start from home directory. So this is the home directory. Under your home directory, you create a catkin ws folder, and under the catkin ws folder, you create a source folder. Okay, so this line means create from home, create this folder, and under this folder, create this folder. That's the meaning of this line. But you don't need to do that because it's already there. Okay, but if you freshly install ROS by yourself, you need to create it. All right. Then cd. cd means enter or go to the particular directory. Okay. Again, you can see this wave symbol. This is from home, so which means you specify. Because if you don't do this, you need to specify the full path. The full path means /home/username/ here. Okay, but every time we use this to how to say, for shorter, so that you don't need to specify every time specify your username and home. Okay, just tell and like this is from home. So cd means you enter the catkin ws folder. Right. So this, after you type this, your current directory is at the root of your workspace. Okay, the catkin ws is the root of your workspace. And then you do this catkin_make. This is to build your workspace. You can do it now. cd this one, and then go to catkin make to make sure that your workspace is properly setting up and your code is everything is okay. Okay, no need to do the first one. Huh? This one already done. You just do this and this. Okay, and you can see your catkin make, it will run a list and then you will count from something until 100. Make sure everything is properly compiled. If we give you error, please tell me, right? It's important to make sure your workspace is properly compiled. You don't need to type in the $sign. This is a form. Okay, every time in my slide you have this $sign means this is a terminal command. Is everything okay? Okay, to make sure your catkin make is okay.
Catkin make is like compiling the.
Yes, yes. It will compile the whole workspace. It's okay? Okay, alright. So after you've got like 100%, which means your catkin make is fully compiled. Okay, now you want to start to create a new package. Okay, this is the first step when you want to start any application. Okay? You want to start develop a new application, you start from creating a raw package. You can see the reference over here. Okay? So first, instead of go to the root, that's how we are at the root of the workspace. Instead of go to the root, you should create your package under the SRC folder, which is the source folder. Okay, so you CD, you enter the source folder, and you can see a lot of package under there. But this is where you create a package. And please listen carefully. If you create a package outside of this, it's not going to work. Okay, you should create your package under the source, under the captain, inside your workspace. But recommended to put it under the SRC folder. Don't put it somewhere else. So that you have, this is the convention to keep your workspace organized. Right? But actually, if you create under captain.s, it still works, but follow the convention, you should put it under SRC. Alright? Okay? So, can you see like this is not a dollar sign? Okay, this is not a dollar sign. So don't type this. Don't type this and don't run this. This is not a dollar sign. Alright? So only type anything behind the dollar sign for the command prompt. Okay? This one means it's a command. Alright? It's a command for this thing. So to create, once you are inside the SRC, to create a new package, you use cat-kin underscore create underscore package. So this is the command to create a package. And after you type this one, the first word, okay, or phrase is the package name that you want to create. And make sure this name is unique, which means you should not have something similar in your source file that have the same package name. You have to create a new package. That's why over here I recommend you to, for example, write your own name or whatever name. Okay, make sure that you don't have a package name that already exists. Okay, so you can create a package, and this one, if you need a space, you need to put underscore, because if you put a space, it means something else. Okay, so you cannot have any space. You need to put underscore. So beginner tutorial. So this is a new package that this tutorial will teach you. But of course, I recommend you to write in another name. It doesn't matter. Any name is fine. Right? So you can write your own name, tutorial, whatever. Okay. Then after this, you can specify the dependency. For example, the dependency, in order to run this package, you need the standard message. Standard message means it's a library in ROS that you need to use it. And you need to use the library of ROS EY, ROS Python, or ROS CPP. Okay, so these are the dependencies. And actually, by writing your dependency here, is actually to ask the compiler or whatever that when it compiles, it know that you have this dependency so that this thing can successfully execute after that. So even if you don't write any of this, still fine. Okay, but don't write wrongly. Okay, make sure anything that you write here is correct. Okay, if you don't know, don't write this, it's fine. Okay, but I will say raw standard message, you always need this. Raw device, you always need this. You always need this thing. Raw CPP, not really. But it's up to you. You can put it in, it doesn't matter. Okay, but at least these two, you definitely need it. As long as you are writing your source code in Python, then you need it. And a lot of operation, you need the message. So this one is. Okay. But again, if you don't write any of this dependency, it's still fine. Okay, it still works. Important is this command and your package name that need to be unique. Right? And after you create this, a good practice is before you start writing any code, you make a hit. And in order to make, you need to make sure you cursor back to the root, then only you make. And make sure you make and then 100% no error, then only you start to write. Understand? Okay, yes.
If the name is not unique, will it overwrite or what?
It will give you error.
Oh.
It will tell you like the name or reject. Yeah. Okay, so a good practice is always after create the package, cat-kin make one time to make sure that your workspace is everything is right, then only you start write your code. Because once you start write your code, there's a possibility that you can compile fail, especially like for example you write the syntax error or whatever things that you've done. Okay, you want to make sure that before you write any code, the workspace is error-free, no error. Okay, then only you can identify where is the error later on. Okay, so this is the first step to create any application. So make sure you know this first step by heart. So everything okay? Is everything okay? Alright? Okay? Right. Okay, so now, ROS publisher. So you can write a simple ROS publisher using Python, and you just go to the reference. And subscriber, you just go to reference. And then your assignment is to reproduce the talker and the listener in Python code in your own package. Okay, to reproduce that. And then you can learn it by upload to GitHub and so on. Right? So this is the assignment. So now, because of the time constraint, I will straight away go to the source code and explain the source code for you. You are going to do this during your lunch hour, okay? Right, so let's go back here. So let me open this. Okay, so this is the guide to write a simple publisher, right? I'm going to explain the source code line by line. Make sure you need to understand every single line of this one. Okay, that indicates how important it is. Okay, because I'm going to explain to you line by line. Okay, so you ROS CD to your beginner tutorial or whatever tutorial or whatever package that you created just now. ROS CD. This CD is the ROS version of CD that it will straight away jump to the package that you created. So just now, after you created your package and you click in make, you should be able to ROS CD directly jump to the package that you created. Okay. Is the font too small? Okay, let me increase the font a bit. This is okay? Or I need something bigger? Yeah, I think this is okay. Alright. So first is ROS CD to the package that you have created. And then you can see again, after you have jumped into the root of your package, again it says mkdir. Just now remember what is mkdir? Make a directory, which means create a folder. Okay, so this is also a good practice. Doesn't mean that you need to follow it, but it's better to follow this as a beginner so that you understand what is the common way of doing things. So always, if we want to write Python code, it is considered a script. Okay, it's considered a script. So we make a folder called scripts under your package so that we know your Python source code is under the script folder, right? So we gather there. Then you cd into your script folder. Okay, right. Then there are two ways of doing this. I want you to not following this way. Okay, not following this way. I don't want you to use the wget. Okay, I don't want you to use the wget. So don't type this. Okay, you are going to from this step. What I want you to do is. What I want you to do for this step is learn how to create a file from your editor. You understand what is the editor? What editor you use? The one that recommend in the system, we recommend use VS Code. Okay, VS Code, because VS Code I think like is the open source and is the most user friendly, I would say. But of course, if you are hardcore Emacs or hardcore Vim user, it's fine. Okay, use any editor that you are comfortable with. If you don't have any preference, I recommend use the VS Code. Okay, you can in the command prompt you can type code and it should jump, or you can press on the icon and it will give you the VS Code. Alright. So from the VS Code, I want you to learn from the VS Code create a file under this location. Okay, that one is GUI. I believe you know how to do it. Okay, so using the GUI of VS Code, create a file under this location, okay, under the script, and the file name is called talker.py. Okay, not talker, but talker.py. Make sure you have the py. Okay, create that file, and then over here, you copy paste the content of this into the file. But before you copy paste, make sure you toggle the number. Okay, don't copy the number. Okay, and since you already learned Python, you understand the spacing is very critical, so be careful. Okay, make sure you copy the spacing without error. Okay, copy paste this whole thing. You see, it's just this two line. It's only you see plus the command. Everything is 20 line only, right? So it's very short. Okay, so toggle the line number and then copy paste this into this file and save it as docker.py. Can you do this operation? Please do it now. Make sure your docker.py is under the script folder. Okay.
This one.
Yes. Oh, okay. Create in your shell code. Okay, make sure you don't copy the number. Toggle the line number. Don't copy the number. Toggle the number. Toggle line number. To use VS Code is up to your preference. Okay, I'm not going to force you to use my way. How to use the editor you learn by yourself. Okay, so step one is under this folder, create a file, then docker.py, and the file contains this content. Okay, that's what I want. Okay, can you do that? Is everything okay? Are you done? Done? Just copy paste the file. You should not take so long. Is everything okay? Okay, anyone lost? Anyone stuck somewhere? Is everything okay? Is everything okay? Everything okay? Alright, so if everything okay, can you go back to your terminal? I want you to back to this location. Okay? And when you cd to script, okay, what I want you to do is type ls, enter. ls. Okay, tell me what you see. What you saw? Docker.py, right? Okay, and what is the color of the font? White color, right? Okay, so in Linux, there are actually a few layers of what we call privilege. So a file can have, I think like 3 types of operation: read, write, and execute. Right? And it got 3 layers of user: own user, group user, and general user. Okay, right. So it has the permission level to allow a particular file to be read by someone, write by someone, and execute by someone. Okay, and the color that you see white means it is not executable by, I think, the third party. Okay, but for more detail about this permission type, you can go and search Linux and the permission file permission thing. Okay, right. So what the objective that what I want you to do, the next action is make this Python file executable by third party. Why you need to do that? So that ROS can run your Python code, or else it will be forbidden by the Linux system. Okay, and in order for it to, you can check the ls dash a. If you dash a, then you can see it will come out with the permission level, right? ls dash a, then you give it the permission level. You can see like x something, right? right? So that is like the 666 or 644 or 777 or something, right? If you know what is the jet. Right. So in order, so just in summary, okay, I'm not going into the detail. In summary, to make the Python file executable by ROS, all you need to do is chmod plus x means allow executable, and then point to this file. And then you enter. After you do this, you ls again, your file name becomes green. Okay? And that means okay. You can check the -a to see what have changed. Yes.
So you have to make this for every new code that you make?
Yes, for every new Python code.
New Python code.
Yeah, because Python is a script. Basically, you don't need to compile, it can run. After you have compiled the package, you just need to create the source code and it should, like the Python code, it should be able to run. Okay, so you only make this once because like this is the only way to make the system able to make the ROS able to run this code. So you have to do this step. Make sure you remember this step because if you forgot this step, it's very hard to debug. A lot of people just forget. Don't remember this step and everything just look fine. Then until it keep on saying like cannot find the Python code, you see, yeah, a lot of my students say the file is over here, see. Then the ROS keeps saying like cannot find the file. Alright, so make sure you don't miss this step, right? Okay, so now come is the very important thing. I'm going to explain this line by line. Make sure you don't miss anything. So I want everyone to get ready before I explain this. Are you ready? Okay, so now you have already copied the Docker file in a properly created package. Okay, so now let me explain to you how to create the Docker file, right? So first, the first line is important. You just tell the system where is your Python environment. Okay. Then the second one, basically this is not important, it's just a comment about the license file being removed. Okay. So the third line, okay, the first thing, what you need to do is import ROS UI. Just now I said the dependency is ROS UI, right? So in order for your Python code to be recognized by Python, that's right, by ROS, because you can run any Python code and it can still run using the Python way. But now you want to write a Python code that can run by ROS. Okay, so this is the ROS library for you to write the Python code. Okay, so it got the ROS function that is meant for Python. Right, so you need to import the ROS Python library, file library. Okay, then okay, so this is another way. From standard message.msg. So remember this thing. This is the data type. Remember, just now I explained the data type. So standard message.msg. This one is also a standard message that is used in ROS that you already create the data type. This one very similar to your standard message in C, but they are different. Very similar, but they are not the same. Okay, so this one is defined in ROS. Okay, right? Okay. Of course, you can search this file, something.msg, and open up and see what is the impact of the content. Okay, you can see it, but you can do it later on. Okay, so from this message, you got a lot of definition. You import the string because you want to use the string. Okay, you want to use the string definition in the standard message type, right? So these two lines basically you just copy. Okay, but the meaning is import the ROS library, Python library, and also from the standard message type, you import the string so that you can use the string. And this string is basically different from the string you define in your C or in your Python. Different. Okay, this string comes from the ROS. So there are slight difference in terms of the definition. Okay, but you can assume they are the same, but they are different. Okay. Right. So. Okay, so this one maybe you understand. This is a Python. You know Python, right? Okay, so this is the main function. So the main function, basically what you do is just try Docker. Basically, you just run this function and no more. That's all, right? You catch something like interrupt. So this one is you have the exception that if you do Control+C, it will stop the operation. Okay, so you catch this is the interruption, right? So if you Control+C, then you stop this whole thing. Right? So the main is just to run the function. Okay? So it's just only one function, very simple. So the function is called Docker. Right? You understand this? It's called talker. All right. So always, I prefer to write line number 8 first. Okay? Line number 8 is ROS PY, so you get from ROS PY, this one. So inside there is a function called initialize node. Okay? In every node, for example, this Python file, you want to make this Python file into a node, ROS node. You add this. Okay, so ROS UI.initialize node. Okay, to initialize node, to make this thing become a ROS node, you need to tell a few arguments. First, you give the name. So this node is called Docker. Right, so in ROS, when you run this source code, you will have a Docker node. Okay? Right. And then anonymous true. What is this anonymous true? You can read down there, they got a detailed explanation. Basically, because in a big system, there will be a lot of nodes. And the tendency for your node name to be clashed with some similar node name is very high. So in order to prevent the clash, we put anonymous true, which means ROS will automatically add some number behind here that is not visible for you, so that it don't clash with another node having the same name. Understand? Okay? But you don't care if you don't understand, also just add it. Right? But if you want to know, read the detailed explanation down there. Right? So this line initialize this as a node. Called Docker. Right. Then after that, I have this. So this node is already done. The second thing is I want this Docker to publish something. So I need to create a publisher. Okay, I need to create a publisher. Keep in mind, in a node, you can have multiple publisher and multiple subscribers. Okay? In one node, you can have multiple publisher and multiple subscribers. Okay? Right. So don't ask me whether how to create the second publisher. Do the same thing. Right. So to create a publisher, first you need to create a variable, a handle. So this is a handle for the publisher, number one. And to create a publisher, first you need to define what topic you want to push. And if this topic is not exist, it will be created. Right? So publisher first is the topic that you want to publish is called chapter. Okay? And then you need to define the data type associated string over here. Correct? String. And the queue size equals to 10. Okay, you don't need to care about this queue size because the queue size is basically like the buffer size. Okay? And this will only be critical when you are talking about nanomillisecond. That you have your operation is not fast enough, then that's why you will miss something and you will, but you're not handling that. Okay, your operation is far slower than that. So you don't really need to care about it. Put 10 is fine. Right. Then after you have the handle of the publisher, that means you already define your publisher. Okay, you can publish to this POV, right? Okay, then you create because that's how you ask me like why it keep on like repeating, right? Because over here you can use this under the ROS UI some function called rate to have a function to control the speed. Okay, the speed. So for example, over here I define the rate to be 10 Hz. I want my loop to be 10 Hz. I create it. Later on you will see how to use it. So while not ROS PY is shut down, so that means that when this thing is not shut down, so we think this is infinite loop, right? Okay. So while not this is not shut down, until you say you interrupt, say you want to shut down, this will keep on running. Right. So you say hello, so this one is a parameter. You say this parameter is basically the hello world, and then you plus a time. This is get time. This is just a counter, like counter. Okay, you ignore this part, so it doesn't matter. Okay, but this one is just to give you the number so that you can see the hello world is different. Right? So hello world, just want to see the number at 0, 1, 2, 3, 4, 5. Okay, so this. Then ROS PY.log info. So log info function is basically the ROS PY way of print string. Printf. So we are going to print this on the terminal, on the screen. Okay, but this line is not publishing. We need to make it very clear that print it on the screen and publish this message into the topic is different. Got it? Okay, right. So this is basically just to show what is inside here on the screen. Right? What makes this message enter the topic is different. So you publish, you create here, right? So after you create, you have the method, which is publish. Then you put in this value into this to push this into this. Got it? Okay? And then you skip. Okay, why you skip here? Because this is the while loop. So how long this need to wait in order for this loop to be entered? It will automatically calculate. So this while loop will sleep for a split second so that this loop is entered. Because this will like vary every loop because like depends on your background operation, the computing operation and so on. So this will be automatically taken by this function. That's all. So I basically explained the 20 line in this to give you the understanding on how to create a Docker node that you can publish some value as a message into a topic container. Okay. Any line or any logic that you don't understand in this. I want you to be crystal clear on every line. I basically explain every line to you. Okay, this is so important that I really pick up one and explain line by line. The rest of the code, I'm not going to do this, right? If I do this, maybe 1 month or so, I can finish. Okay, but this is so important that I need to explain line by line. Okay, question?
Is queue size important?
No important. It will only be critical if you are running a very big system and your computing rate is very, very high. Okay? Or you are transmitting a very big volume of data. Okay? But for a whole application, this is not. This is like buffer size, I say. Down there, they got explanation to read later. Okay? Yes.
So in terms of publishing and printer, so when we print, we cannot flip the. We have to flip the look info.
Oh, sorry. What's the question?
What is the idea of look in or printer?
Look info is basically a function under the ROS-py to display the value on screen, on your terminal.
Okay.
Okay, but it don't mean that you publish that value into the topic. It don't mean that. It only print out the value on your screen. Okay? We do not. This is just to display. This one, you throw the message into the topic. It's totally two different operations. And they are not related to each other. You can remove this log info and it still works fine, but you cannot see anything. Yeah, your terminal will be after the first line, then stop, then nothing after that. But if you print for your topic, you can see the message in the topic. So this one is just to show you that what it sent into the title topic. But they are not related and separate composition. Question?
So to look at, you say I have many nodes in one project. Do I do it in different VS Code files or no, I can do it in the same code?
It depends on how you define your node. As I said, we always write one node to create one function, but how complex is your function? For example, your function is to read from a sensor or to publish the data to someone. So this is one. Okay? Then you want to publish to someone, but you want to do other things to publish to do something else. Then you create another node.
Okay, another question. So in the VS Code, we did name for file as a token.py. So when we run in the terminal the node, is it the file name or the name we specify here?
The file name.
File name.
Yeah. The node name over here is just to tell ROS that the node is named Docker. But when you want to execute, you do ROS run the package name and Docker.py.
So if I have many nodes and I put token.py, that means all the nodes in the file will be run, right?
No, only Docker.py.
Yeah, but in the token.py, I have many diff, like Docker, many diff.
This whole thing will run as
one.
Yes. So this is one node. So advisable to split your function to separate them. Yeah, don't put everything together. As I said, the philosophy, the architecture is to discretize the function so that you can reduce the code. Okay, any more questions? Question? Okay, no more question. Good. Let me go to the second example, which is over here. You can go to this one, the subscriber, but basically it's the same page. You just scroll down. Okay, so now let me explain the listener.py. Okay, so this one. So you can repeat the same way how you do for the talker.py to create the listener.py under the same folder. Yeah. Okay, maybe I speak too much. Okay, so after you have created, okay, see, after you have created this, whatever that below is just the description, okay? You can ignore this, you don't need this, okay? You don't need this, okay? You don't do anything, you don't change the CMake list. Don't do this. A lot of students do this and yeah, something wrong happened. Okay, don't need whatever I tell you, just follow it, okay? Right? This thing, you only do it when you understand what you're doing. If you don't understand, don't do it. Right? Okay. So this one is just to explain like how I explained it now. Okay, so the next one is again, go to your CD, go to your script folder, and then create the listener.py and chmode plus x of your listener.py. It's the same process, right? So we create another file called listener.py with this information put in the file and make it executable. So it's the same thing, right? Is it okay? Okay, I'll print it. Okay, I'll come back. Have you done?
Yeah.
But you can do it later. Okay, let me explain first. Is that okay? Because it's the same thing that you repeat how you create the talker.py, you create the listener.py. Okay, it's nothing new. You just open up your code and then you just copy this and save as file and make it executable. Remember to make it executable, okay? Alright, okay, so now, just now I explained about talker.py, now I'm going to explain about listener.py. So for listener.py, you see the first line is the Python environment, okay, so you just put hash, and then you can see you import the same thing, and from this one you import the same thing, okay, so it's the same thing, so everything is the same. Okay, now you can see the listener is still the same, just run the listener. This one, okay, so and this is the listener, but you realize that other than this function, we have a callback function. Okay, I'm going to explain why this happened. Okay, so look at the listener function first. Okay, you can ignore all these things. Okay, so this one you see. So as you can see, the first one to do is to initialize the node. So I make this into a node in ROS called listener. And on that should, okay? So it's the same. Then to create a subscriber, you don't need a handler. Why? Because the subscriber just listen, you are not going to do anything. Okay? So just listen, and you need to specify which topic to listen to, which is the setter, and then what is the data type. And the last one, this one different. Just now is the queue size, right? Okay, so for the listener, it don't have the queue size because you want it to listen as fast as possible. Right? But what importantly is what happened after you got the message. You are going to subscribe to a topic, you are going to get something, right? So what to do after you get the message? This is the callback. So instead of a handle, it needs a callback function. And this callback function is defined here. And this callback function is the process you are going to execute after you receive something from the topic. Okay? Okay, now so let's see what is in the callback function. And you can realize that in the callback function, you need to have a data handler here to receive the data. Okay, this data will contain the data from this topic. Okay, so I receive the data over here, then the operation is very simple. Anything I receive, I just display on the screen. But I plus the caller ID, which is you also don't need to care about it. Right? You just say I heard something. Okay, but important thing is why this is data.data. Okay, it's very confusing because like if I write this code, I'll put this as message or something. Okay, because this is message dot data. Then maybe you can understand the of the data type. You still remember when just now when you want to publish manually to the topic chapter, you write ROS publish ROS topic PUB, the topic name and the data type, and then you have a double quotation data, semicolon, then a single quotation, single dot, then you put your data in. You can see there's a data equal to something. Right, correct. So in the message for the standard, this one, it actually have a lot of things. And then it got one which is data equals to your message. Okay, so that is the data structure. So in order for this to print, because this log info, it only can print string. So you cannot print, for example, an array. You need to make it into like a string. Okay? So you are going to print the value under the data. Okay, sometimes a lot of times like students stuck here like, sir, how come nothing come out or something like that because of the data platform? This is also the reason because Python they just hide everything, so you don't know what happened inside there. Okay, but to explain to you, this data is the value of this value. You understand what is the value of that? The value. Because in the data structure, okay, if you still remember, I need to go back now. I need to go back to this one. Where is it? I can't remember. Yeah, this one. So can you see like data? So it's under here. So there are a lot of things other than data. So you need to specify like I just want to print the value inside it, not the S.
So I can put data dot step to get the other one maybe.
Provided the message type to indicate got that thing. Okay, but apparently you are doing like you can check what is the standard message slash string. Sorry. Yes. Correct. Standard message.msg. Inside there is a string, for example, like string, and then under the string got the data. Okay, so that is the data structure thing. If you are interested to know the detail, you can go and find out. Okay. Okay. I just don't want to make things complex to you. So the simple way to explain this data is to bring the value of this data into it. You understand, right? Because like for example, this one %s, %b is critical, right? Yeah. So that's why. Okay. So that's why this is %s when this is string format. So you will fit in other format, then it's not really. Alright. So the callback basically is just a print. But if you have, for example, a logic like if your input is high, then what you do, if your input whatever, so this you write in your callback function. And that's all. You see, the listener is even shorter. Okay, and again, I want to repeat, in a node, you can have multiple publisher and multiple subscriber. Okay, but you maybe have callback 1, callback 2, callback 3, and so on. Okay, got it? Yes.
Can I ask, right, what if I put the rows type info under the subscriber line? Is it possible?
Where is it? Here.
Here. Like without having a callback.
Because when you read from this slide, maybe it don't go in that way, but the sequence will be this, will go to this. Because the callback is only here.
Because if I don't put any callback, just
so this is the way how it works. Okay, this is the way how this is the syntax. You need to follow the syntax. So this is the syntax. So this is how it works. We understand that the callback is not good because like you cannot have in a window. But I don't know why. Not in design too. Okay, I think it follows some. I don't know. Someone actually told me this is very similar to C#. Anyone know C#? Okay. So then. Right. Okay. So that is how it works. Right. So this callback and this is how. Yeah. You cannot do that because this value won't appear here. Okay. But one more thing. ROS py.speed. Okay, so this is something tricky. Although the name is spin, this is not looking. Okay, again, Ross dy dot spin, although the name is spin, but in logic reading, this thing is not looking. Okay, it don't look, but it just made this thing continuous. Which means you do like this subscriber will keep on listening. Okay? Yeah, because subscriber you're supposed to keep on listening. You don't need to write a loop for the subscriber to keep on listening. Because if you write a loop, then you need to specify like how frequent it listens and so on. But there's no this kind of concept over here. So this spin is basically keep the Python from existing until this loop is stopped. So which means it just keep this thing alive so that this subscriber will keep on listening. As you can see, just now you stop the Docker, this thing is still running. When you manually publish, it straight away pops here. Then it wait again. So this, although it looks like this is looping, but it's not looping, it just makes this thing. If you don't believe, you can put something here. It only appears once. Okay? That's all for listener and talker and listener. So this is how you can publish subscribe. Okay. So after this, I'm going to train you using this to use the example. So for example, what's the time now? Yeah, 12. So I'm going to show you, like later on, like I'm going to show you one function, for example, how to make things speak, then how to make things listen. And you are going to combine these two machines. Okay. So in your lunch break, please go through this so that you can catch up. You don't have much time to prepare, to practice, so yeah. But I spend really a lot of time on this because this is basically, I believe if you lost until tomorrow afternoon, you still ask me questions that is related to it. Very sure. I think this for many years. Alright? Okay, so we're supposed to break for lunch. 12 to, as I said, 9 p.m. So break 1 and then we start back at 1. Okay, so yeah, my timing is just right. So I finished it. Basically, let me see my slide. So yeah, so done. So this part already done. Okay, this part already done. So your assignment is basically to do the publisher and subscriber until you understand fully the whole thing. Okay, so after this, I'm going to break for lunch, and then we'll come back for the second part, which is the speech interaction. And in this part, I'm going to show you the function, and I'm going to give you the exercise to apply the public subscribe into this. Okay, so so that's why I say the whole workshop is showing you one function, and you use the public subscribe to assemble them together. For example, you listen to something, then you're supposed to say something. Okay, and this operation is in public subscribe. And you call the node and so on. So this is how the program works. It's very different concept with your live program. But this works. Okay? The way how you create the development maintenance. Okay, so without wasting time, I'm going to free you for the lunch. And then we'll come back at 1. Of course, you have a question, you can answer the question. Yeah.
We have an unrelated question from the live stream.
Okay.
Do you please have some hint on how to use Jupyter ARM in inverse kinematics mode? We control individual joints by sending messages to controller nodes, but we would like the actuator to reach specific X, Y, Z position. Is there URDF for the arm or node that can perform inverse kinematics?
Model. So first you need to understand how the model works, and then you need to understand like how the move it. So how you can use the move it to send the goal position, because we already like specify the goal position, but the demo only show how we use the interactive marker, or we can specify the XYZ. But you can actually do the same thing, like you can program to send the XYZ as a goal position and make the move it to calculate the inverse kinematic formula, right? But anyway, this is not actually part of the content that we intended for this workshop. For more information about this, you can email me directly, or we can discuss in another channel. Okay, but in brief, yes, you need to learn how the model works, how to use the move it, and how to send the goal position to the move it so that it can use the move it to do the inverse kinematic and give you the planning and move the arm. That is the answer in short. All right, thank you. Is there any more? Okay, all right. Yes. Any more? Don't have. Okay, so without any delay, so let's break for lunch and we'll come back at 1 p.m. Right? Okay, see you. Yep.
Yeah. The model.
So I'll stop here. And I don't know, you just keep it running, right?
I can end the live stream and then start again later.
It's up to you. But I would say just leave it and you cut later. Is it easier?
That's fine. Okay.
Yeah, because like if you terminate it, then people have to like reconnect.
That's true.
Yeah. So you just look at this
Yeah,
screen.
I can just put it.
Yeah, you just focus on this screen and then you just stop. You just focus on this screen and you just stop. Okay, so it's not updated.
Because I have to open Meets first and then they will update. So I'll just show this.
Yeah. So this is the lunch break.
Lunch break.
Alright. second part. Right, today my target is to finish the second part and start the first half of the third part. So that tomorrow we can continue this one and then we can finish off. Okay, so that is the target, right? So we need to speed up a bit further. So I might jump or keep some part. Right, so for the second part of this workshop, we will be talking about speech interaction. So the purpose is very simple, is to make your robot or your machine or whatever that you're creating able to have the capability to talk to human people, not human, to talk to human in natural language. And talk to is, we need like the synthesis, which is the robot have to sound like human, okay? Conveying the message in human-like language, right? You're not like, for example, please go to XYZ. People don't understand that. Please go to the toilet in front of something, then people can understand. So you need to explain or express in human language form, right? So that is to convey the message. And also, interaction is two-way. So the machine or the robot has to understand what humans say as well in human language. All right? So this is the speech interaction. But for speech interaction, it actually contains a lot of components, but I only focus on two, right? So which is, the first one is the synthesis, the second one is the recognition. So one is to speak, and one is to listen. And try to, not to say understand, but try to see what is the word that you speak out, right? Because to understand the content and to generate appropriate reply, that is a different story. That's what we call the dialogue management or dialogue engine. Okay, so a good dialogue engine or dialogue management or things, a very good example is like the ChatGPT. So whatever that you put in, then it can give you very meaningful answer. Okay, but that is separate because that itself is a big topic, so it's not covered in this workshop. This workshop is only give you the very, very basic infrastructure, which is your machine able to speak like human and listen like human. Okay, but how to generate the meaningful reply and all those things, that is something that for you to explore. Okay, all right, so we focus on these two things. Right, and to do this, basically it's very simple. You already have all the components you have, like you can use your laptop, that all the modern laptop now equipped with the speaker and the microphone. Right, so no problem, you can do that. And the software is the software that we use. Okay, so you can even do this without ROS actually. Okay, everything can be done in Python, but we do it in a ROS way or in a ROS framework so that you can connect this part with the rest of the component. For example, the vision component, the navigation component. Okay, so that is why we also do this thing in the ROS framework. Okay, right. So first, I start from the speech synthesis. So basically, this is text to speech. So you input the text, and the machine can read out using the human voice-like system. Okay, so speech synthesis is the production of artificial human speech by a computer or other machines, also known as text to speech. So a lot of time it is written in TTS or text to speech system, where normal language text is converted into speech. And inside here, it is actually not as simple as what we think it's like. Because for human, we can naturally produce, from reading a sentence, we can naturally produce the sound and read it out naturally. But inside there is actually involved quite a lot of things. For example, like first, it analyzes the text. So what are the texts inside there? The text form certain words and so on. And that comes to the second one, linguistic. So what is the grammar? What is the relationship between all the words and what is the sequence, and is the sequence give you some particular meaning things, and also the punctuation. You know, when you have a sentence end with a dot and end with a question mark, it can mean differently. But the content, they are the same. Right? Have you eaten? Have you eaten? Then there's a question. So, for example, I have a sentence that ends with a dot and ends with a question mark. So it changed the meaning, and not only changed the meaning, it also changed the intonation. Right? Because you change your intonation from a normal sentence to a question sentence. Right? So that one in the waveform generation, so it actually also relate to what is the grammar, what is the linguistic analysis, and so on, right? Then it generate the waveform. So when you generate a waveform, you also need to think of, for example, what is the intonation you want to use, what is the speed, like when you say something in a very sharp tone or in a very fast pace or slower pace, it not only gives different meaning, but it also bring up some character. Like, you know, like some person talk very slow, some person talk very fast, or some person they actually talk very fast in certain condition, which actually give you a different meaning. So there are actually a lot of components in speech synthesis that you can fine tune so that it can sound very human-like. Okay, but today I'm not going to go through all those things. I just want to tell you that there are a lot of components inside there that you can explore. Okay, right. Okay, so our purpose now is very simple. I show you the way how you can type in a line and the machine is going to read out that. And the next person listen to what the machine said can understand your meaning that you written in the text. So that's the purpose, right? Okay, so first, and I'll show you the online way. Can you see like Google Text to Speech? I have a square bracket online, and later on I have the offline. Okay, so first let me explain what it says online and offline. So for both synthesis and recognition, we can actually do it in an online form or offline form because like the speech research and services is already like very matured and we have a lot of openly available services online that you can use. For example, like over here, we use the Google Text-to-Speech services, which is it actually provide the free API or limited usage that you can straight away use the API and ask the server to actually do the service for you. Which means like you can send like one line of text and the server will tell you how it sounds like. Okay, we'll give you the result of the waveform and so on. Okay, so that is services. So when we do this thing, then we use the online services. So this is the online way, right? So that's why I recommend online. There is a benefit and also drawback of this online way. The benefit is the quality is much better. Okay, for online one, the quality is much better because we rely on external resources to do the processing, to do the fine tuning, and there are a lot of things behind there that happen that bring up the quality of the service. But the drawback is you basically don't know what is happening inside there because it's a black box. I mean, if we use, unless there is open source services, which mostly is not open source, like the Google API is not open source, you don't know what Google server done inside there, so you don't know. So one thing is, it is not open source, so you don't know actually how the process is done. But if you don't care, you just want application, then that doesn't matter, right? You just want a very quality service. The second drawback is it requires internet connection. So if you are not connected to the internet, you have some delay or your robot is out of the coverage of the Wi-Fi and so on, this service will stop. I mean, like it cannot continue. Okay, so this is drawback, right? But of course, the quality is much better and so on. Later, you can do the comparison. Okay, so in order to do this, I need you to do a few things. So first thing is, before you continue with this, you can find down here, there's actually this resources bar. So can you see this Google PDS.py and Google SR.py? Okay, right. So you can download this into your I/O, and then it will appear in your download folder. Okay, but you need to put it somewhere else. So let me show you where it should be located. So if you go to our GitHub, I'm going to show you RoboCup. So if you still remember our repository, okay, so now I want to introduce you the repository. Okay, so now if you go into your Catkin, so can you scroll in? You use those that with the I/O. You can go in your file browser. You open up the file browser. You go into your Catkin WS. Okay, you can see maps, develop, source and so on. So go into the source. All right. So go into the source. Right. Okay. So inside the source, you got like basic function packages, Jupyter robot, etc., etc. Right. Okay, and you can find one folder called RoboCup EDU Learn ROS. Don't look at this. Look at your file browser. Can you find under the catkin WS source, which is the location where you created your package? Remember that? Okay, so now I want you to browse inside that folder, and can you find a folder called RoboCup EDU Learn ROS? Can you see it? Okay, so basically that folder is this one. Okay, so you go into the RoboCup and you hit clone this, basically you get that. Okay, but the thing is, inside this folder, you actually have two missing files, which is I added afterwards. So can you go into the RoboCup EDU Learn ROS? Are you inside there? Can you see there's RoboCup EDU apps, RoboCup EDU ARM, mapping, navigation, speech, vision, etc. Can you see that? So it's the same like this one, right? Correct, right? Okay. So now I want you to go into the speech. Go into the speech, this one. Okay? So inside the speech, you can see this speech is very similar file structure like your package, right? You've got a script, you've got a CMake list, you've got a package, right? Alright? Okay, so now please go into the script. And in the script, you can see three files, right? Is that correct? Okay, so you download the two files with Google TPS and Google SR put inside the folder. Unzip that zip file and then put these two files into this folder. Can you do that? Yes, correct. Don't put in the zip file, okay? Unzip and put the source file. Okay. After you put in these two files, I want you to go from your terminal to this directory and check if this two file is white or green color, which means are they executable? If they are not executable, make them executable. Okay, I hope you remember your exercise before this. So make this two file executable. It's white. It's white, right? Okay, make them green. You remember how to do it?
Oh,
Everything okay? Alright. So now please check LS to make sure all 5 files are in green color. Yeah, make them executable. Right. So if you're okay with that, let's go back to this. Change mode. Right. So once you have done the copy of the file, basically you add into source file into the RoboCup pitch package. Okay. So I want you to install this if it is not available yet. So please install this The software that we are going to use for the Google text to speech is this one. Okay, so you can use the pip install. This is the Python program, Python software. So you pip install GEDS. To see if this software available in your system. If not available, please install it. Open up your terminal and do this. I believe maybe some of you they already installed, because in the previous workshop maybe they already installed it. PIP install GTDS. But anyway, you just try, and if not installed, then you will install it. Make sure your computer is connected to the internet for this to work. Is it available?
Change that.
Is it okay?
开了来着。
你要先把你的这个来源放上，然后来
因为它来比很少不了。
Is it okay? You can install. You need to install these two components or these two software if they are not available in your system. Install this and install this. So this is an exercise to show you that you can actually install additional software, install additional source code to this system so that they can work together. Okay, and for the terminal, you can try to learn how to use the tab for autocomplete. So the tab can help you to autocomplete some tasks. Okay, class, please tell me, can you install the tab, or is it already exists in your system?
然后你去那个
Is it okay? Yeah, please give me some response that if it's working, the terminal it's already installed. No, it's not installed now. So you install now, right? So both installed. Okay. Alright. Yeah, let's try to install this. Yeah, you can delete on the computer. Make sure you make the two file executable, okay? How to do it? Please refer to the slide before it. Right. So after you have installed this, you can start testing your code, okay? To test your code, first open one terminal to run the raw store, and then another terminal to run the node. Right, to run the node. And the third one is to publish some words into the topic store, into the node. And you check if you can hear the hello world from your speaker. This is not a file. This is a command to install software. So trying to do this to see if you can hear the words, the hello world from your speaker. Yes, yes. Then you open up another terminal to filter one. Because it's waiting for you to input some. Oh, this is waiting for you. It's listening. It's listening for you to tell the node what to say.
哦，它就跟它大的路上到原来的地址。
Can you hear the hello world? So this is the first example of hello world now. Run and then do this. Both these two, let it run. Then do this.
The ROS run, we do it under the hotspot as well.
No. This is one terminal, another terminal, another terminal.
How do you have a
So we can get the hello world. Okay, good. So I heard one.
Erlacenia.
What is better working for? It did work. Yeah, it's a try.
Oh.
Why is this happening? Why
Okay, so I can hear hello world means everything is working now, right? So everything is working now, right? Okay, so now I'm going to explain you the code. Right. So can you compare this code with your subscribe? Yeah, so you can see this, right? So the code for this TTS. Okay, let me show you. I'm not going to explain the whole thing, but just go through the Python environment. So this one is the same. This one is the same. Can you see? From GTTS import GTTS. Basically, this one is we import the function from Python, which is we import the how to say the Python function that you just installed, right? And then we import OS is basically some function that you mimic your execution from the terminal. Okay, but yeah, that's over there. So can you see this is very similar to your subscriber, your listener, right? Because we have the main, right? Everyone please listen here. You got a main, and then you got the function which is Google PTS, and then you got a callback function. Can you see? It's very similar like subscriber. Right. So inside here you can examine again. You initialize the node, and then you do a subscriber and you speak. Exactly the same, right? So then in your subscriber you can see the input is the topic that is subscribed. It listens to a topic called input, right? And then it actually throw the message that we see from the input into the callback. Okay? And the callback, the same thing, you receive the data, you put in the data, and then just now you just display, right? So this is just to display. But other than display, it do something else. First, it converts the value into a text parameter, sorry, this is a variable, and then it send this to this function. So this function, you don't care what it done inside there. Basically, it just send this to Google through the API and do some processing and come back with the result. So this line basically, whatever that you type and send to the input, it will be sent using this function to Google API, and it will come back with the answer. See, this is the answer. Then from this TDS, it saved the answer into an MP3 file, which is a WAV file, and then it used the MPG321, which is a player, media player that just how you install. It play the file. That's why you can hear the hello world, right? And then it delete off the temporary file. Basically, it's the temporary file. And delete off, and then done. Then it listen again. Then if you send again, then it will say again. So you can see this thing is something that already complete by itself, and it is structured in such a way that it will listen to topic that you send. Okay, so now if I go back here and you look back from here, can you see? This is the input. So I manually publish this data into this topic, and this is the data format. You got the whole idea? Understand the whole idea? So basically what you have done is you create a node, okay? It listens to one topic, and then you publish manually some message into the topic, and this one, because it's subscribed, so you will listen. It listen to this message, it's sent to Google, come back with the answer, and then play it out. So you hear the hello. And this is how you can make your machine speak something by sending whatever text that you want to a topic in ROS. Can you get this? Anyone got any question about this?
Yes. So this node is subscribed.
This node contains a subscriber. Yes.
Content to subscribe.
Yes, I show you right now. Yeah. So I open up this code, right? Remember? Yeah, this code is this one, right? This one, right? And it contains a subscriber. Can you see over here? Contains a subscriber. And the subscriber call back that works once it receives certain message.
So when we manually send a message to the topic, that acts like one-time use node publisher, right?
Yeah. So you can actually now, normally I will give the first exercise, which is instead of sending the message from the terminal, I want you to write a publisher node to publish this message to this node. Can you do that? That's the first question. Can you do that in 10 minutes? Can try. You understand, right? Okay. I'm going to write. Okay. So now you have a node. Oh, sorry. Now you have.
Try, Doctor, this one. The blue and purple one behind you.
This one?
Yep.
Okay, so now you have something that what we call this is TDS, right? Okay, so this is a node. All right, and then maybe a node better. I think maybe you prefer it now. Okay, it's a node, a circle, right? So now you have what is the topic here? Input, right? Okay, so what is the relationship here? Subscribe. Correct? Can see this thing. Alright, so you have a node. This is your Google TDS.py. It actually subscribes to a topic called input, and you manually from your terminal input anything in here, and it will read it out. Okay, so now now you have terminal, right? $sign, then you do something, then it sends in here, right? Okay, so instead of $sign terminal, can you do a node to send something? Okay, can you do a node? This is a new node. Okay, this is a new node. a new node that will send some input, then it will read it out. Okay, so this is ideally this is the first exercise I'll give, but I will skip this. I will straight away do the second one and you combine two exercises. Okay, but this one, if you think it's not hard, right? Basically, you just modify from the Docker and it works. Right? You got the idea, right? Okay, so now we skip this part and we go to the next one. Let's go to the next one. Okay, so I'm going to skip this one because I want you. So for the offline means instead of using Google, we are going to use a software that runs locally in your machine to do the synthesis. Okay, and that one we are actually using a system called Festival. It's a software in Linux system that do PDF for us. But it can do a lot more, but we use the function. And this one is already built in Ubuntu, so we use this. And then in order to use this, we need to use a wrapper so that we can use it in ROS. So the wrapper for this is basically what we call the sound play. Okay, sound play is a basic component in ROS that gives us the functionality of text to speech. Right? So you can go to the wiki to read more. You can even go to the tutorial to learn more how to use it. Okay, but I will show you one example that you're going to be using. Right? So you run this, run the sound play node, which is very similar like that one. And then you just use another node to key in a argument, and this node will send this thing into this node to speak up. Right? And you can actually open this soundtest.py to actually see how this thing works. But I'm not going to go through this unless you want to use this later on. Okay, so I just tell you about this example, but I want you to focus on this exercise. So this one, you can run and to see this, but you don't need to care much on this because I want you to use the Google one first to learn the example. So now, just for practice, please run this tree and see if you can get the hello world. You should be able to get something very similar.
Just now I using the problem for the Google one that the type one those four is distributed and then another one here.
Yeah.
And then the third one.
Because you use copy paste, right? So when you copy paste, the double quote actually give a different meaning. You retype this again.
Oh. Thank you, doctor.
Yeah. So
The Google one is much better.
okay, so I just want you to compare. This one is locally produced, locally processed, and but Google one sounds better, right? No, that's the quality. Okay, but the benefit of this is even you shut down your Wi-Fi, this thing still working. And this one don't use your internet resources, so you don't have any letters to your internet.
How are you?
Okay. Okay, so if you want to learn how to use this, you can open up this template. .py to use, but I will say you just stick to one system first. Okay, you will learn this when you need it. For example, you want to reduce your dependency on internet, then maybe you want to consider it. Right? Okay. So now this one done. I'm not going to show you the source code, so let's continue. Okay. Yeah. One of the reasons why you say it sound not so good is because like maybe it's a female and male sound, so maybe you want to change. So for this speech synthesis festival, you can change to other, but even I understand like some you need like female voices. Yeah, you can download this package, but there are a lot of detail over here. So this one later on for reference, you can modify the voice package and play with it. Okay, so we can change the sound and so on. Right, but I'm not going to go through all this thing. Okay, so now, the idea of this is I want you to actually create a node to do this. Okay, but to save time, I'm going to skip this part so that we can combine directly the recognition and the EDS together. So now let me go to the second part of this. So the second part of the, so it's this one. Okay. Okay, this time we are going to do the serious exercise for that. Okay. So for the second part for speech recognition, right. So to understand speech recognition, it is actually the process to extract the speech content from a human voice. Human voice. Like whatever I say, then the system will try to capture and try to extract what are the words used inside that voice. Right? So sometimes it is called an ASR, which is automatic speech recognition. Right? System converts spoken words into text. And this is from this paper is just one of the examples actually. Speech recognition is a very broad research work that have a lot of approach to do this thing. And now even not only because this is very traditional thing to do like pattern matching and stuff. But now you got a lot of deep learning stuff and everything has become very fancy. But the idea is basically because we know human voice eventually is a wave, right? Right? So from the wave, you have taken signal processing. Right. So signal processing, you have the signal. So you can actually identify features. You understand features, right? Features is a waveform that appear or standardized in the wave. Right? So there is certain features that what we call. So we extract the features and then we compare the features with something that we have learned. For example, these features mean this sound. These features mean this sound. So we extract out and then from there we know like these features belongs to like this word. Alright, but this is a pattern matching way. So now got a lot of way and then so this can be quite complex if you want to learn by itself. Right? But it is one of the computer science field that study on all this signaling for speech recognition. Okay, so again, same thing, we use the Google Speech Recognition API to do this. And in order to do that, first you need to install the speech recognition. This is this is one of the, I think, very popular Python software that have the architecture to use a lot of different speech engine for speech recognition. But over here, you need to be very careful that we are using the 3.8.1 version. If you are not using this version, you use the latest one, it will give you the error. Right, so make sure you install this version, right? And then after you install, you can basically run it. And then follow what the instruction from the terminal. You can actually, speak to your speaker and see the results. So can you please try this? Please try this. Okay? That's why I like it. Can you try to do this?
More.
Everything okay? Yeah, please tell me if you face any difficulty. Okay. Let's go.
Let's do this.
To pay attention on one small detail, right? So sometimes your recognition maybe is not so sensitive. It's because like there is one more parameters that you can tune, which is the gain of your speaker, right? So now I want to show you how to do those things. Can you go to the setting of your Ubuntu system? You can go to the top right hand side and then open up the setting, or you can see the gear icon. You can click on that. Okay, so everyone please open up the setting windows. And in the setting windows on the left hand side, you can find there is a tab called sound. Got it? Right, so once you open up the tab for sound, you can see there are actually 4 tabs in the right hand side. The first one is the output, right? Everyone, can you see? The first one is the output, right? Yeah. Right, so for the output, there are a few. So those are the sound card output that you can use, right? I don't know which one is currently selected. You can try, there's a test speaker. Can you see that button down there, test speaker? So you can select one of it and test the sounds, the test speaker to see if that is a good output. Yeah, if it only have the center, that means that sound interface is not so good. Maybe you want to choose another one. For the I/O, maybe you want to choose the one with Unitech Y247A, and that one seems like it's better one. So you got the left, right stereo one. That one maybe is a better one. Yeah. Okay. So this is the place you can choose which sound card to use for your speaker. You can also choose your internal built-in sound card that the sound will come out from your laptop instead of the I/O. Okay, you got it? So this one is for your speaker. Then I want you to go to the input, the second tab, input. Okay, so in the input, same thing, you got a few interface. You should be able to select one of the things. So for example, like in the robot, we actually have a lot of different speakers. So you can choose which speaker to use. But after you, for example, I select this speaker I want to use, okay, I select this one. Then you can see the input volume and input level. Can you see these two things? Okay, so what are these two? Input volume means how much you want to apply the gain. The gain means whatever signal input, it will amplify. Okay, but please be careful because you need to adjust this according to the input level. Alright, so first you select a sound card that gives you some changes in the input level when you speak to your microphone. And the effect that you want is when you are not speaking to your microphone, your input level should be almost zero. But when you speak to your microphone, your input level gives you as many tabs as possible. If it gives you very small, maybe you want to increase the input volume so they give you bigger one. But don't increase in such a way that even if you don't speak to the microphone, it has some noise sound there, because that is the noise. Alright? If you increase the gain, it also increase the noise level, which you don't want, because that will disturb the recognition. So the optimal way is choose a sound card interface, the speaker interface that you want, and then increase the input level in such a way that when you are not speaking, it gives you zero input level. And when you you speak normally to your microphone, it gives you the maximum input level. Okay, so that is the effect that you want. So it depends on different environment. You always need to fine-tune this parameter. Okay, remember this. This will definitely help you to improve your recognition rate. Okay, so can you tune that nicely, then go back to your recognition and see if your recognition improves. So is everything okay? You need to. Is everything okay?
Say nothing.
Yeah. When it asks say something means you need to say something.
Hello.
The microphone is over here. If you choose this microphone, that will show which microphone you use. You need to choose the correct microphone, right? Make sure you know which microphone to choose.
现在有那
Okay, so make sure that you have your system able to recognize.
我刚教。你要这样。
The first
Eu vou dar uma.
How different have a try.
One more additional information about Google API for synthesis and for recognition. You can actually change the language to other languages. For example, Malay or other thing, Arabic or so on, as long as Google API support it. Alright, so if you say like, for example, you want to change to Chinese, yes, but you need to know how to change the setting in the source code. Right, so is this working?
I have problem with the publisher. The technology gives me like you check it the clock. Check if the clock is time. No message. Yes.
Testing 1, 2, 3.
This will go.
It's not working, right? So the next is not receiving any right? Okay. So if this is working then.
Last time
Okay. For the first time, if there's no input, you can. Right. Now, right. So for the SR, okay, SR is slightly longer, but it is not much different. For the SR, these are the same, and then again we use the speech recognition that we installed as SR. So over here you can see the main is very similar like a publisher, right? So the main, and then you got a while loop, which is this is something that you're going to do. So first you initialize your node. Okay, then you create a publisher, and the publisher topic is the result. So which means whatever that recognized, we want to publish into a topic called result. Right, and then everything is the same string. So while your ROS is not shut down, it will run this. So first is your SR is going to get the audio from your speaker. So it will get this one, and then it will send it. So this one. So this one say something. So it will record whatever that you get from your speaker into a variable called audio, right? And over here you can see I actually comment out this listen. Instead of using listen, I use the record. Okay, there's two ways of doing this. If you don't, because you realize that the current logic of this example, I written in such a way that it actually records 5 seconds, then give you one result. It give you 5 seconds, then give you one result. Okay? Okay. This is because if you didn't properly configure they call it the environment energy level. So the listen is not going to work because the listen will automatically start the recording and stop the recording based on when you start talking and when you stop talking. But if your energy level, which means like if your noise is noisy, then sometimes this listen is not working, which means it don't know when to start and when to stop. Okay, so this will give you a lot of error. Unless you know how to properly configure, like there's another parameters that you can set to set the energy level, which is what is the environment noise level. Then this listen can automatically listen to you. So every time you don't need to wait for the 5 seconds. Every time you say something, you stop, then it will give you the result. Okay, but this will give a lot of error and you need a lot of tuning. So I don't use this. I just hard coded so that it listens 5 seconds and give you the result every cycle. Okay. Right, but of course you can like play with this and choose. You can modify this code, right, according to your usage. So this, it will record a duration 5 minutes 5 seconds. It will record whatever that it listens in the 5 seconds and then send to Google. And then it come back with the result. Okay? So this is how the logic works. And this will keep on looping. Okay, any question about it? Okay, so now come very interesting exercise. So now I want you to create a system that you ask the system question A, it answer you with the answer A. If you ask question B, it gives you the answer of answer B. You understand what I mean? So you need to play with some logic. Okay, so now I want you to create another node. So now you have another node called SR, right? Correct? And then you have a topic called result. Correct? And you are going to publish this based on whatever that you listen, right? Okay, so now I want you to combine these two. Example, I want you to combine. Combine doesn't mean that write these two code into one code. It's not like that. Okay, I don't want you to write these two code into one single piece of code, right? I want you to combine as a raw application, having two nodes, but you link them up so that this system will listen to you. So when you ask question, for example, like question number 1, okay, don't say A, question number 1, then this thing will reply. This thing will reply with answer number 1. If you ask question number 2, then this thing will reply answer number 2, and so on. And if this becomes a lot, then you have a chatbot. Understand? So I want you to maintain this structure as close as possible. Try not to modify too many things. And do this. Can understand the question? So you have a node. You have a node that can listen to you, right? So after you get the result, you can do some simple logic to see is question 1 or question 2. Okay? Then if question 1, then you send the result here so that it can pick up answer 1. Or answer 2 or answer 3, depends on the person. And this is the first version of your chatbot. Okay, but of course this logic you can connect to your ChatGPT API and then it becomes a very smart chatbot. Okay, so this is your exercise. Okay, so now try to brainstorm among your team members how to do this.
Okay.
So in this case,
yeah, that is one of the answers. That is one of the things that you need to modify. Yeah, you can separate. For example, like you do one more node, you can do one more node in between to subscribe and publish. You can. Okay, if you don't want to create, okay, there is a way that you can create one more node to do this coordination. Or you can just modify from this one. Okay, so now I give you about 30 minutes for you to do this. Is that okay? So you need to be hurrying. Yeah, as we don't have much time. Yeah, you can ask me question. All right, ask me question. Sure.
Oh, 水做不这样。
Yes.
And sauce, okay.
Create a new package and copy the code. Okay, create a new package, copy this two file into a new package and do things there. Okay, after you modify the code, then you don't have the original one anymore. Or if you don't want to create a package, you can still keep using this package, but create a new file. Okay, always back up your original file. That's a practice.
Yeah, the content.
Yeah, a good practice will be create a new package. Okay, but if you lazy to create a new package, you can continue to use this package in Linux. But as a practice, it's better to create a new package, everything created like what I've shown you in the first lecture.
So sometimes you just need to move the camera. And then you can see sometimes the page is not updated. You just
Make sure when you create a new file,
refresh this page and then
okay.
so and then the YouTube goes to here. I'll be back in a minute.
Oh, okay, right. Okay, yeah, it's a long hour.
Hold on, I changed the battery.
So if the slides not appear,
Refresh the page, just open the page. You go this one? Yeah. You just do this and it's really refresh.
oh, okay.
Yeah. And then you can just go here. Yes, you can see what's the camera doing. One you can zoom in and out.
Anyone not clear about the question? You can ask me, I will explain to you.
Oh, 你看。最多。OK，让我们太长哦，没有。他这个是，他是我读出来，啊，他就抄我的回去。现在我用完了这掉那个，这掉啊。哦。
So a simple logic.
Okay.
Hello. Check the pen, the fact. Okay, I can give you one more tip, okay? Okay, I can give you one more tip. Okay, over here, there's actually an example called talkback. And what this talkback try to do is it will listen to what it recognize and try to say the same thing. Okay, so this might give you some hints. But this one is using another recognizer, so the note is different. But something that so this actually gives you some hints how to actually do that. But not necessarily this will be helpful because this is using another system.
No answer. What I mean
Okay, class, if you really lost and don't know how to start, or maybe after you write everything and it's not working, always don't try to be more ambitious. Try the first question and answer. Just keep one. Try to capture one question and give one answer. After this is working, then only you continue to do the logic for question 2 and question 3. Okay, do one question and answer first. First one.
لا مو عنك هو
来了。
The simplest way is just modify your SR and the EDU is
No. 他 print 他这个 print out 啦，我觉得。我们是认证用手上。啊。
就这样啊，好好释放了。有些好。好。
要讲跑啊，要讲我定要啊。
刚刚有个错。
好啊。
采购又是在采购。
是的。
How are you? How are you?
I am good. How are you? How are you?
I'm good. How are you?
I'm tired.
That's cool.
I'm good. How are you?
It's the one to control. Okay, just 1 second. Oh, sorry. I'm sorry. How are you?
Yeah.
Oh,
那些上海都负担单数。
Oh, what does this kind of shy, man? Lish? Love.
Get close to answer.
Yeah, it's actually
It's also a level of obviously.
Oh.
我是做管理的，我少的啦，
那个
How are you? How are you?
How are you?
Name.
你这个在哪边看可以存在？是在哪本？怎么说？我们刚刚这么看过，我说的。三个介绍，我本来这里这个那个，
因为你可以只是然后你要把两个东西变成啊，才可以把它当东西然后变成它不然没有可以这样子搞定，要 check 好要把那个 check 换进我们知道那个把刚刚那个做到它的答案换进那个空间里面，然后一个是专门的概念我们的成功的check 到那个。他都买了，对，我们再看看你们线的话，就是线嘛，对，然后给你个给，然后给你，然后再过来，他变水仓，那时候我们这里做你要 publish 一个里头是一个不了，你要去。它这个哪里啊？这个它是比如说，它是是用那个谷歌没？谷歌这是没有看，没有看，这是配给你，你要改就可以了。改这张图片你要可以就是拼出来，把它改出来，它去，因为没可以。还有什么？这个改的是都可以以后没有还是。这是他的作品啊。对吧？我这个他们真的那个，其实这个我都觉得怎么讲啊？我觉得这里还在问，因为照样上回你知道这种你当时他就把你放进去，所以应该是把这个改成一个本来是这样。你这样子你这个是，然后你这样子很难，然后就是它不是啦，这应该是在这边啊，你刚讲的对啊。它这个人类嘛，然后如果你全面滚正常也是可以的，你就是你滚正常好挡避。啊，那你就直接解答，他就不用滚正常，一手手答案去点，然后他就会解答案，直接放答案出来了。这个你要看你题那边，然后这个所以，我知道你那个大家还不累呀。
这我跟你讲，你们我开始还是比较好了，我操的，这大声。进来啊！我刚才去摸那个鸡，那个鸡的，我也是这样，就那种样。都比这个，So you have this. Okay, so what you have? Yeah, because you didn't specify where the package. What package? Cross run package A.
这 A 比简单啊，我简单。
是那个话，打一个哪怕3个字啊，我也得去啊，还是 E。
Who are you là how are you?
Cái đi này là sự mô hình. Maybe I like to to how? Alexa. Alexa. 所以这个东西都可以把它使用的吗？
就是拿到那个回程时间，然后完了。
Make again. Yeah, I think it is.
Everything? Anyone already successfully created the solution for it? Okay, good. You can do a demonstration.
I can. Just we doing the packages now.
Name.
Hey.
That's true.
Это заводится сейчас Rosco, станции заводится.
What is the name? What is your name?
What's your name?
Why name?
How is the weather?
Okay, have you source your workspace? This one you install by yourself, right? Yeah, to source your Yeah. So that way we open up a new Right? 5 minutes. Make sure. Yes.
Oh, this game will do.
Yes. Something we can have a stop. Lunch. Oh, sorry. Yeah, and what? So the result of SR is the result that you publish the result. And then the one that you want to get print out is the answer. What result? After Google returned the result, I published into the result. So this is a result of the SR. But what you want the EDS to bring out is not this result, but the answer. The answer is based on what is the question. The question is actually inside this result, not the answer. You understand what I mean? So maybe you want to try to change the name so that you are not confused. Yeah.
And you can recognize the audio then check that connect, you know, then you will generate output audio. Then upload the answer. And
But have you published this? No, up there. Have you created an output topic? This one. See, here is publisher is not, it's not an publish to the topic. First, you need to create the topic. You need to tell publish to which topic. All right, so time's up. How is it? Right, just pause a while. Never mind, you can continue whatever the work after this because I have the last 1 hour to complete for the class today. So this exercise actually is how to say, it's very important for you to test yourself if you understand the concept of public subscribe. Okay, and how the ROS node everything works. So if you fully understand what I have delivered this morning until now, then you should have the idea like how the node works and then how to talk to each other and how the public subscribe. Okay, so try to use this exercise to make yourself fully understand the concept. Right, so once you understand the concept, you know how the thing flow, everything will be simple after that. Okay, so any part that you're not sure, try to look a few more times. Try to refresh back what I show you in the public subscribe. Okay, slowly catch up the concept. Okay, right. But I need to tell you a few more things before I close this session. It's like for the speech recognition. So the example that I show you is just for the online, which is you use the Google. So basically, it's a black box. You have no idea and you have no control over the result. Okay. But anyway, the result is good enough actually. So we actually have another example that uses the pocket speak to do the speech recognition. But this one is more tedious and the accuracy is not very high. But the advantage is this is open source, so basically you know exactly and you can control what is actually happening. Right? So, and this one it used the language model. For example, like language model, we download language model. And then these are two examples. So inside here, you actually have two examples that you can play with to see how it responds, like keyword spotting mode and this LM mode. LM mode is a language model mode, which means we create a very small language model and then we use the language model to do the recognition. All right. I don't have time to go through the detail of this one because this is for the long workshop. But just want to introduce to you that we actually have this example that you can go through. So maybe tonight, if you want to have a look and everything, yeah, you can look at it. And we can even recreate or modify the language model so that you can recognize different words. Okay. But this is to practice so that you understand how recognition works offline. You understand like how the process and what are the recognition is done. Okay, what is language model and so on, right? But for very short and intense workshop like this, I don't have time to explain this. So I will leave this to you, and if you want to have a look, you can have a look, you can try out, and so on. So I already put down link, CMU Spin and ROS Pocket Spin. So these are the things that you can go to the specific link to read further, okay, if you're interested in this. Okay, right. And as a closing for the speech section, there are actually a lot of more things that we can add in so that you can build a very nice chatbot. Okay, for example, like you can connect this. For example, like what you have done is this part and this part, right? Right. So there are actually a lot more things. For example, like cloud detection and localization. This is useful when you are talking to a group of people. For example, like now I'm interacting with you, right? Then some student asking question, another question asking question. So I need to know who and where the sounds come from to identify who I interact to. Because like later on when you create your service robot, it might need to entertain a big crowd. Right? So this sound detection and localization actually help the robot to know exactly where the sound comes from or who is asking or interacting with you. Right, so this part is something that we didn't put in here because this one also needs dedicated hardware. For example, you need a microphone array, like several microphone in an array form, so that it can actually detect the difference of the speed like how our ear actually can detect where the sound come from, right? Someone actually calling your name from behind, you actually know that sound actually from behind. You know why? Because the sound wave actually enter both your ear in different speed. So from there, your mind actually automatically calculate where the source come from. And also when you talk to different people, different person have different pitch, different sound and so on. Our brain actually automatically analyze all this so that we understand, like when we are talking to a group of people, we know like this is talking to this channel and this one is in this channel and so on. Right? So we can actually build this complex system on robot, but you need additional hardware. So that's one thing. Another one is this speech understanding and dialogue manager. Okay, understand is something that is very debatable. Okay, how to explain if the machine able to understand what you say? It's not easy to have a very how to say clear answer on this statement, because like how to prove that the machine understand what you say? Is it because if the machine can provide you appropriate answer means he understands? But what we want is not whether the machine understands you or not, but the machine able to provide you the correct or the appropriate answer. Right. So that's why you may say ChatGPT is very smart because it gives you very good response that you want, but whether ChatGPT understand what you ask or not, that is a different issue. Right? You understand what I mean? So over here, our concern is more on how we can develop something so that the robot can actually give meaningful answer based on what's the question or the comment from the human. Right. So this one is actually we categorize in the dialogue manager section, which is it by itself is another development. So you can add this thing later on. Okay. There are actually a lot of online tools that can give you this dialogue manager or dialogue engine services or API that you can plug in. Okay, for example, the ChatGPT API, basically you can actually connect with the Google speech and recognition API, and you can actually ask the ChatGPT like you talk to him or her. I don't know whether it's him or her. Right, so you can actually do that based on this. So with that, you can actually like create very nice what we call the smart speaker or like your Poker Google. But just now when you try, you can actually realize a lot of optimization can be done, right? For example, like the microphone actually pick up the sound from the speaker, so it recognizes itself. So how to do that? And also the how to say the speed or the turn base when you speak to the machine. For example, the timing. How we to control the timing so that your question and answer is more smoothly and so on. So there are a lot of things we can do to make this robot very, how to say, smart in terms of communicating with the human. Yeah. So yeah, these are the things that you can actually improve and further develop from this. But I hope this provides you a very basic form of human-robot interaction system that eventually you can extend to many more applications. Okay, so I'm going to show you the next part, which is the vision part, and I will give you one example and also exercise to show how you want to connect your vision with this speech part. All right. Okay, so let's go to the next section. Okay. So I'm going to introduce this half of this, then I will give you some assignment for you to do tonight so that you can practice, and tomorrow I'll continue the second part of it. Right, so for this one, normally we have actually three parts. The first one is RGBD sensing, the second part is OpenCV application, and the third part is actually the deep learning based or machine learning based image processing. But I have to remove the third one because we don't have time to do that, but tomorrow I'll show you some example so that you know what else you can explore, right? Okay, so mainly I'll touch these two parts. So the first part, RGBD sensing. Okay, for RGBD sensing, if you have the Jupyter I/O, you can use the RGBD sensor on top of it. Or you have your own, for example, like you have the Kinect sensor, you can use that. The I/O is using the OBEC Astria, or you have the real sets, you can use that as well. As this one, these are all belongs to the RGB sensor. But if you don't have all these things, you can still continue part of the example using your webcam or USB camera. All right. Okay, so these are the things that require for this workshop. Okay, so robot vision. Generally, we have two big category of vision sensor. One is using the camera base. Another one is using the laser range finder, the distance. So one is measure the distance, one is measure the color. Okay, and over the year, we actually have a lot of improvement. For example, like from a single point form laser range finder to a plano, and then now we have like 3-dimension LiDAR. Okay, and then also from camera, we have like webcam, and then Kinect come in and it actually combine the color with the distance together. So we have RGBD, and now we got more and more RGBD. And also inside here, we also have, for example, the stereo vision and so on. So in robotics, we actually have a lot of vision-based sensor that you can play with. Right, and for the RGBD sensor, this is one of the very old application of this old Kinect. But I think like the latest one or the one that you have now is almost maybe the resolution is higher or the frame per second is higher and so on. Okay, but this is the basic specification that require for our development in service robot application. Why? Because it's like originally this Kinect sensor is designed for gaming, the Xbox, right? So it wants to track the movement of the human so that it can use this interface to have some to design the interaction for the game. For example, like you can do the sports in front of the Xbox and so on. But for us, we use it for service robot. So for example, over here we have this tool, which is the RGBD. So particularly this one, we use it, for example, to interact with the person in front or to interact with the object in front for the manipulation. Okay, so it got the color, so it can detect visually what is the object. It also has the distance, so that it will be useful for us to do the planning for graphs, to measure the distance and so on. Okay, right. So why they can make the RGB sensor like low cost compared to laser sensor is because instead of using laser, it's actually using infrared projector. So this sensor, it can bring down the cost, but it got the problem outdoor. So this sensor will not give you good result if it is exposed to sunlight. So this is something that you need to remember, because like a lot of time we tend to forget about this, and then we bring this robot to outside, but the sensor just gives us wrong data all the time. Okay, right. So this is here's the info. You got the color and the text. Right, and the distance sensing, I think like this one, everyone understands. The physical concept is using the time of flight, which is the laser beam will shoot out and then it bounce back from the object, and then we measure the distance based on the speed of light. Okay. Right, and for color sensing, we have this one is very similar to your CMOS or CCD. This one, it actually changes the light intensity to electrical signal, and then we use the RGB filter to filter out so that we know what is the R value, G value, and B value. Okay, so this one. Okay, so visual perception challenges at home, the competition, or in service robot is actually very high. Why? Because like as compared to if you are coming from computer science, you do computer vision, you understand that in a lot of time, we have very clean background, right? And also we have very simple object like a monotone color and so on. But in home environment, it is very colorful and it is very noisy, I would say, right? So you need to detect object in this environment. For human, it's very easy because we already like how many years you have trained your brain and your eye to recognize object, right? So we have already trained a lot. So if you understand CNN, convolution neural network, you understand that how CNN work is basically the same as how your cortex, your brain perceive color. It is almost identical process. Okay, so we already trained our brain for a long time, so we're able to recognize things. So for computer or for robots to do the same thing, we need to actually do very complex like learning and so on, so that it can recognize very colorful object from a very colorful background. But what I want to say is like human technology already have a lot of breakthrough. For example, if I'm not mistaken, like in 2015 or somewhere there, computer vision detection rate is actually higher than human detection rate in certain conditions, right? So which means our computing system, computing power is actually more superior than human being. Okay, so for example, like you don't feel threatened when calculator can calculate faster than you, right? So no need to worry if computer vision can detect things faster than you. No need to worry. Okay, it's just same like the calculator. Okay, the calculator is not going to take over the world. All right, but we need to acknowledge that we can use this powerful tool to help us in a lot of applications. Okay, but the challenges is there. So these are the challenges. So our challenge in atHome or service robot is how we can use the visual perception to make the robot understand very noisy and dynamic environment and also object. Okay. Right. So there are parts inside the visual perception challenge of atHome to recognize faces, to recognize objects in different conditions, and so on. Okay. So for the robot vision with rod, how many kinects you have? Oh, can you show one of it? Okay, just in case some of you don't know what is kinect. Okay, by the way, so this is the RGBD. So this is the OBEX. This one is, and this one is similar, although it's much smaller. But they are quite equivalent and give you very similar results. And the one over there, maybe you can use that as well later on after the workshop. Okay, so over here we have some driver or library that will be useful for you. For example, this Open NI tool, Open Kinect, this tool will be useful for your Kinect tester, right? And for example, the Astral, we will use this, right? And for your USB cam, so later on you might want to try out this USB cam. Okay, so you can see this one, right? So this one is very similar to slide recorder. This one, right? So this one. So this and this, they actually work quite identically, right? You can use this later on. Yeah, but you need to modify this to give the power and so on. Okay, because this one you cannot like plug into your USB. This is not USB. Okay, but I just want to show you like these are all very similar sensors. Okay, it give you the color and also the depth sensing values. Alright, so with PCL, which is the Point Cloud library. So this is also another very useful library to help us organize the depth sensing into a point cloud. Point cloud means after I shoot all the light on this, I can get a point, all right, arranged like a cloud, right over here. And we also using the OpenCV, Open Computer Vision. This is one of the very popular computer vision library. We'll show you some example as well. In order to use it in ROS, we actually have ROS has one dedicated community that developed the OpenCV apps. Right, you can go to the website and have a look. It already packaged several very popular OpenCV algorithm into ready to use ROS node so that you can run it directly. So we are going to show you some example over here. Right, so to set up your USB camera, maybe you can ignore this. And for the upstream, this one is using this. Okay, but these are all already set up in the I/O, so we can learn how to straight away use this. Right. Okay. So now you can try both of this. If your computer coming with a USB camera, you can try with this to see if this is working. But for the I/O, you can straight away run this. Okay. So to bring up means we are going to run a series of nodes that to help activate the sensor, so that these nodes will try to get the input from the sensor, organize them into meaningful topics that you can use. Alright, so still remember the line follower example. So this is basically the driver. The function of this is to prepare the sensor value for the model. Right, so you need to bring up this. So can you run this together with me? For those that with IO, you can run this. Okay, for any of you who are using your USB camera, you can use it if you have this. Okay, then you can use this to display the, for example, for Astria, you can use this to display the RGB value or the depth value. Right. Can you please run this to see if you can get the image from your IO? Right. Oh, okay. So I think I Okay, I think I made a mistake here. This is camera, not launch. Okay, because apparently like this one is the old. Yeah, I think this one is the old example. So this should be camera. I'll modify it. So Ross launch Astria camera Astria launch. Is it running? It should be. No, not yet. So that's why you need to run the one below. Yeah, launch is like so now it's already changed to Astria. This one is just to bring up. You are not going to see any image until you run this. Yeah, this one and this one. It depends on which set of data you want to see. So this one is the RGB data, this one is the depth data. Oh, yes. Astria camera. I make a mistake. And then change the Astria camera launch. So this is the color image. So you can try to see the difference between the color image and the depth image. Right, tomorrow I'll show you the filming. Yeah, we can use the outreach to the yeah, it's trying to make sure that So is this working? Right, so if this is working, then okay, so next we'll come to a very interesting example, which is you can take a photo with. So now before you do this, after you do the bring up, what I want you to do is open up a new terminal, okay, and then do ROS topic list. ROS topic space list. I want you to see the list of topic available after you do the bring up. After bring up, do the ROS topic list. Bring up first. After you bring up, then you do the ROS topic list. Yeah, this one is if this is camera. Yeah, and there's a space of Okay, so after you bring up and then you do the ROS topic list, you can see a list of topics available, right? Right, and basically you can see one group belongs to the RGB, another one is the depth register, right? Okay, so the reason why I want you to see the list is because I want to explain the topic. So can you see, when we use the image view, we are actually reading the image from this. So what are these things? So this is the topic that having the camera feed. Okay, so for this one, camera RGB. So this is the RGB data. For this one is the depth register, which is the depth that you have filtered. So this is the depth data and the RGB data. Okay, so this topic contains the data value that you want for RGB and for the depth data. Okay, understand? Right, and that's why you use the image view, you can see that. But if you use the ROS topic list, you can actually see a lot more topic available for you to use. Okay, but so far these are the tools that is relevant to your application. Of course, you explore others to see what are those things. Okay, so for the take photo, basically we are going to use the RGB so that we can actually save one of the frame considered as the photo that coming from the camera. Okay, so in order to do this, I already prepared two examples. One is take photo.py, another one is take photo sub.py. Okay, so what are the differences? Take photo.py, when you run the program, having your bring up of the camera, it will instantaneously capture the current frame as the photo. Okay, but for take photo sub, I add in one subscriber so that it will listen to a topic called take photo underscore photo, and when you give the data take photo, it will capture that particular frame when you send it. So which means when you run this, nothing is going to happen until you send the note. Okay, so why I want to do this is because after you do this, the next example is just now remember your question and answer robot. Remember? So I want you to make sure to make one more addition. Question 1, question 2, then this one. So other than question, you can say take photo, and this one it will answer okay, and it will start to take photo. So which means you got like can ask the robot to take a photo of you. And I think this is a very nice feature. For example, like you have a group of people, then the service robot is moving around, you tell the robot, please take photo. Then you all stand together and the robot, okay, say 1, 2, 3, cheese. Interesting application, right? And it's very easy to do just this one. So I want you to improve your question and answer robot to add in this part by modify a bit of the take photo sub, and you're able to do this. Okay, so now I want you to try to run this take photo.py after you bring up. And before you run this, make sure you check the image topic in the example. Okay, by saying you need to check the image, maybe let me show you the exact code so that you know where it is. So it's under this one, vision, script. Okay, you can see like we have take photo and take photo sub, right? So if you open up take photo, over here, okay, it's very long, but once you run this code, it will straight away save the image. Okay, you will always save the image. So you can run this and see what image is saved. Okay, but what I want you to take notice is this one. Connect image topic. So which means this file have to subscribe to the image topic from your printout of the camera. Okay, so over here by default is using this camera top, and this one is not available in your I/O. So you need to change to this one. Comment out this and uncomment this. Understand? So you need to tell this take photo.py to connect to the correct camera topic that you want. Okay? And the same thing for the camera sub. Okay, so we see this is take photo, right? So for the take photo sub, this one. So the take photo sub, you can see there's actually a subscriber here.
Because I'm not sure.
So I have subscriber, so you can. But here you need to change the topic also. So you change the topic, and then the subscriber is something for you to use so that you can connect. So when you tell the robot take photo of you, then it will say, okay, please get ready, 1, 2, 3, cheese. Then it sends the signal to this, and then it will take photo. So what I mean? Right? Okay, so your exercise before the end of the class is this take photos in your Q&A room.
No, this one was
Okay.
Like when I ask you,
okay. Time to head out. So please try to take photo to make sure that you can capture the image.
我们做完这个是得应该数据的。还有出现了什么？你要数据方面的，我就。
So now you need to do the get it? Understand? If you can, which means just convert the SR so that when you say take photo, it actually sends a signal for the take photo sound. Okay, but do it one by one, step by step. Right? So make sure you test the take photo and OT. And then you combine with the SR, okay, with the SR. If you want to be fancy, you can connect to the TTS so that they say, get ready, 1, 2, 3, say cheese, then what do you think? And even more fancy. So if you run on the in the home environment.
就因为我们都搞不清楚它怎样。
Okay, the photo taken is saved in the current folder means it depends where you run this. Okay, it depends where you run this command. Normally you run under home directory, so this will be under the home directory. One hour not enough, right? You need to eat and you need to do the frying prayer. So I think I should be within 2 hours. Yeah, but please decide the time that tell me when is the start lunch. Before you run, make sure you want ending the topic. Okay. Today is 12:1, right? So we have question 12 different. So we start at 1 and then I get a 3. Okay, so we start at 1, we come at 3. Right, so 1, you can start at 3. Start at 1. Start at 1 and then do come at 3. Okay, so what you want to do now? Tell me what you want to achieve and what you can do. Okay, you try to start all over again. So for this one, first you want to combine these two. Basically, you just change this to the same. Okay, if you don't want to change the DDS, you just change the SR to input. Yeah, so which means the SR will go to the input. That's the first step. Listen. Your SR publish the result of SR to this topic. Okay? This TTS subscribe to this topic so that it will read out. So now the first step, you want your SR to publish to this topic being read by you just these two the same thing. It's either you change this to result or you change this to input. After you change this, whatever FR will recognize, it will read out. Okay? But after it read out, you don't want it to read out what it recognizes, but you want to do some logic. So after you change this, you rewrite the logic, right? So that the result come into SR, it actually will change the content to answer and you publish back to this. You get what I mean?
So the answer should be inside the PDF file or over here in the file.
So you don't need to change anything over it. Okay? Alright, so this one. So just do one question and one answer. When SR detects this question, send the answer to DTS. That's what I see. Do it one by one. If you still cannot, right? If you still cannot, you focus on this one. You write one note, just to send an input to this. You forget about it, Jimmy. Okay? Just write one very simple note that send hello world or something to this so that the TTS will read out. Then you combine whatever that you written. Then you will slowly
we are trying to do that, but you know why the
actually this is because you have to change the SR is the engine.
we try to do this but we do not the syntax.
Syntax error. Syntax error getting a new publisher. Logic error or syntax error.
So we copy the code to the side. Well, let's do the code.
Syntax error means that why does it check?
output 那应该output 吗？
如果你想说这个换 output 的话，这样
Then you publish.
No.
我们 create 一个什么宝贝？我交给你。Before you do anything, make sure your take photo.py and take photo sub.py can work as its own before you combine with your speech.
So now we copy that one.
You know command to there, right?
So let's make
What is your name?
Take on the scope.
好在哪里？
我们地打。
我们这打，
We don't need the No, wait. We are publishing. I don't like I'm copying from here. I don't know. هو سفراكر بالنسبة للتكست سبيش هو publisher مفيد اللوك ده اللوك ده مخليه مش احنا عملنا مشكلة مع القوانين بيقعد يعيد نفسه صراحة ايه It keeps saying like no, it keeps saying take photo. No, I mean I can have a daughter oh yes, so this is not what you're doing.
For
对对，这种还有讲先去澳洲，他进去那里。你到底几算？到处。
具体的学习操作。
吧？你拍是这样拍的。拍了不过你一定要留言。
没有吗？这个没事。
也是你。两个。他是跟你讲的，然后这个还就完整的做完整的，我们的头皮包括我们本来会下面这样子，这样是这样。我现在介绍他，
我觉得你要好，以后不要改。这样子。如果没有是，你现在你想要用来做什么？是我跟他泰国多的，你俩的手指整个里面没有那样写嘛，只用来找到。拍照怎么拍照是用那个那个。你又要表达的地方，robot 讲，1 2 3 7，然后你拍到一次，所以你就把 S out 去两边放在这个扣的方式。哦，会快一点。 وين متعرف الكمبيوتر؟
Have changed the voice? The way this works, the name is made, if you run this file, that's why they
Yeah, you did an update too. This one check what is the image topic of this that you run. Yes, I allow, but make sure you bring back without any fault. You don't just go to
What is your name? 简单啊。
哦，
这个是那个
What is your name?
I must sit down.
No, I built the photo. I saw the photo you see is the photo. Then after that, I actually found the photo. Okay.
他听不到我声音，听不到我。
听到，他一直听到。但是我这个他没有给我。
哦，
这个是我们不跟大家讲，你们买了它，对哦。
What is your name? 好，好的。
因为没有啥，居然那个买这个那个哦，就是那个病毒，在完全看到，所以说就是好
我这还有一个 public one，我们都没有 public，所以我们现在没有 public。
可是我可以看得懂。
运气小组说看到啊。
What is your name? What is your name?
他没有讲的话，他不讲话。
是这里头。
这样，然后 topic 它基本上它的版权就是来要看什么东西的后台运作。它的版权是
Yeah, you need time to actually close the exercise. Just what's your message? Message. When we run it down here, we need to change the what is that over? It's funny like what I don't understand what you're trying to what you're trying to run the because why there are self there is because
the big one.
right, so you need to sell in order for people to know where it belongs to. And the message is actually coming from big app photo. Big app photo. So we need the callback from topic actually so this is actually callback.
他有 display
，Anything to show?
把它放在美术旁边，
对，
美术是topic tag 是那个。
I also have pictures. I can give this to you later. I just need some photo and videos. This looks dark, but this is just the screen. So I'm zooming the picture. It's just quality is very good. Yeah, you guys can use this for the Facebook. Okay, you guys and alright. No, I mean, they're trying to be fair. What is the next recruitment? I think on the celebration. So I'm just looking through the tweets. It seems quite interesting. But yeah, I'll give it further. Look up here. What's your name? Thanks a lot. Not you can I know it. I can shoot it, man. I'll come back again tomorrow. Alright. You're welcome. I'm happy to help you. Yeah, it's very awesome. And there's no one. It's not there. How do you want it? There's a new layer. On you, done, but就是然后这个可以用这样子，了解了解。您好，跟讲好的老师好。我喜欢那个这个因为可能好。他的手机好。
可以再保答可以吗？
我就讲What is your
What is your name?
所以是放，OK，谢谢你，谢谢你。这个很奇怪。所以这讲来，我动的就是零三，他讲比照这样子是，但是如果他这个也，他就跑完了，就是他就拿下去，他又上去，他又再传过，所以他就一直回去，像聊他们讲的对不对？
基本上你看有一个 if 嘛，如果是没有聊的话，你放一个 else， 然后就死掉那个狗，那只要是那个出去的。
还是因为还是该放在里面。
没有，它在里面，它这个宇宙会跳进来，你要把这个讲会跳出去。
因为你看我们上面，我们前面其实没有它有没有就是我们都是没有，它好像都不会 run， 就一直在有 run。也有个这个很大，就是它一直
这样讲的话，所以它的时候那两个这边是你两个人
啊，它没有，它被小孩还是跑下来，就是它会跑下来。对，跑一点，非常它就是它变成它是放东西上去了，但是它就讲你我不然来把它给我哦，这样子。哦，我懂了。把它放下。对，打出来。试一下。哦，就是放，可是过去你就在 L 一很快了，就是跑完 I 1分 L 1，然后再跑。
When it repeats the command,
Yeah.
Yeah. Yeah.
他们是不是得把你的 audio
所以这样的话就是，
他就准备把这个
拍一下哦，拍一下。
你有计算啊？对的。
就你每一个是他们好。
对，动的。
这个口味。
我写完。
不要加 DDS， 所以 DDS 你再加一个叉，然后另外一个 DDS， 它的高位多多的，有这个你我要多一个，多一个法律的，你就感觉 DDS 要多一个法律的。其实没有这些车不欧美在到那个反应，你要直接说完了过程，
有没有可能给你反应？
所以你的 DDS 要反应出来啊。
啊，你看。
EDS 一个 publisher，啊，连 EDS 在这啊，这个没有你必须完了。你们会明白明白。因为你要太高。
How old are you？
你说
我再问过。
打过吧。我说这个你看太高了，我都谈不到一个太点上倍。
这个有点难度。
DS 没有 ，DS 从里面拿到啥？
再加个保密就这样的。
Are you？
不，这个最近然后我说哦，是吗？然后受伤了，他的脸白呀，说这样。他的脸哦，看到我给他切了，他都有给你，一个接起来。啊，我是不看那个不知道，真的真的。
How？
看脸都发来看的，
How old are you؟
التوبيك اللي هذا قاعد يتعامل وياه يسوي له سبسكريبشن واللوجيك اللي احنا
那个 yes，
Yes。讲你了。
关到了。
它对每一个本地生下面的每一次，那个是啊，它给你这个关键性，每一个本地生好到一份，因为它知道。在工作把那个会员写在外面之后，他就一直都写在那里。在里面，他就好像就是没有，因为你放飞了之后，你看挖了，把开发，经理更高。你放外面的话，它是在挖入外面的。所以你的挖路里面就在转，都在把这个来干嘛？你必须要放挖路旁边吗？好像一直放在里面，放在旁边在。他们原本那个他是有挖路的，他是这边。所以我觉得这个是这个，你要知道它的挖路到哪去，还有办法，它对成功。你这样子放一点，我就打算这样子，然后还有一个这样子，还有这样子，因为你这样子的话，不管音量是什么，都会把命吗？明白吗？你这个 L 这个还是会把命，因为这个是在 L 外面，它就来和那个 L 所以你要合格，那来不光这个是啊，一样的。如果你连这么的，对，因为有平常就不会做，你不要这样子的话，不管音量是什么，它都会把命啊。但是他就往也不好，这样子我是一样的。这样子的可以理解到这样子的意思，然后你要讲。就是刚刚我以为他们效果是会一样的，但是还好没有这样子的话就对了嘛，啊，这样子对啊，我觉得这样子就对了啊。那我们再接下来，我觉得这样子，没有，我觉得这样子就对了。好，谢谢。再加入
嘛，你问题是两个 condition 是对应的话，你的那个 result 那是我做了没有的，所以你需要了解一个 value，现在我们现在的哦，你 Google 的 result 是这个 result，然后你的 answer 也是一个怪不得你 user。所以你刚刚讲就是话讲的，就是那个我换之前还没有把这个牌子给选。哦，这样我把没有，你这个放在这边会带一个。哦，那这个我改，然后后台就没有。一个逻辑不歪咯，这样 L 是这样，然后 L 是这样。对两点讲，我的逻辑不到这个。想说，这个如果我们说，
Can we wrap up the live stream for today?
Well, maybe I go 15 for 15.
The doctor is really like a short.
Yeah.
Because I have to get going.
Actually, I really want to do
你旁边这个 output 的话，等一下是反转高。另外一边或者让我按那个老，按那个换的，因为换点别的，自己搞乱掉了。
然后把这个
我怎样connect？
反正我们现在如果这么做，然后我们就没有想在
他就会讲不够出来，他会做我刚才明白。所以你的ES 要有一个保险，所以去 control 那个结构，知道？对于然后就是来我们在把 reach which is EDS foundation。对，你就把这个整个做的太长了。对，你要讲这个，我这个，你把这个这边你要讲这个。逻辑就是你讲的话是没有。没有，其实不用，你讲个东西，你今天其实不用搞，你不要考虑什么，没有人那才把你一个逻辑啊，说只有你讲的话是，当然你这个我才会教那个通话呀，其他说单讲的是个概念啊，没有，现在你的那个多的那个 note 你要做出来的结果，然后没有排到来，说都不可以讲，你或者讲有的结果出的话，
加入这个，
所以呢，比较方便
这里讲做一个
跟你先讲，或者我你可以放这个，
我是讲它会这个变高，好像我是讲的是，
你可以放个苹
果版先的，排到，
所以这样你不用排到。 SR 就可以 send 一个 message 里面有多个 house 再 send 去，这样子你查出来的这个你如果可以是一个 delay 的人做的话，如果你我 SR 发现到你的工作的话，首先先 send 一个一句话交给 PDF 的时候，你后面关注这些，
我都要另外再。
比如说你打一个，你再 send。我都去给这边
没有，你前面开始，然后你前面开始，你刚开始
就这样啊。如果我讲这个tick photo， 然后我是有他 publish 这个 tick photo， 然后他那里他就 tick， 如果他是 tick photo， 他自己拍啊。
你们先考虑一下，我那个，
所以我 try to
那个点过一点。
Okay, so let's summarize what we have learned today, no matter whether you are ready or not. Okay, where's my mouse? Right, so we already complete the first part of the LGBT sensing. So tomorrow we will continue to show you application on the vision. So tomorrow we will show you using the OpenCV, for example, how to detect faces, how to detect color, or how to track colors and so on. Right. So all the OpenCV application, we will show you how it can run in ROS, and also I will show you not just playing with the string format, but you can actually subscribe different format, different data type. Okay, so that you can do more things. So that one I will show you tomorrow morning. Right. So today what we have learned is first you learn about the concept of ROS. So it's very important that you understand how we actually design the ROS system. But today maybe it's very new to you, so you need time to digest. So I really hope that you can redo the practice, the exercise, so that you understand the concept of ROS, how you want to design the node, and how you want to design the communication between the nodes. And this whole thing, after we assemble, it will become a meaningful application, like what I've shown you in the exercise. Okay, so please, if you have time, try to look through the Q&A robot, the question robot application. So you can try to change different type of question and so on. And then also you can incorporate with the take photo. So now you have more things to play with, like how to control the timing, when to say what and do what. Okay, so try to be creative and try not to change too much on the basic part. For example, like the ETS, if you if you can write something that is reusable, that would be better. Actually, ideally, we want to keep the TPS and SR without changing anything, but we write a new node that interacts with everything. Okay, but that maybe got some difficulty. So you can actually change the SR and the TPS so that you will reduce your modification, right? But there's a balance between that, because like if you keep on changing the file, then your file becomes too customized and not able to reuse. You can't reuse the things. Okay, so it's up to how you design. And I recommend you to actually draw out the diagram. And in fact, in ROS, you can actually use the RQT graph to see how the node and the topic connect to each other. So when you run some, for example, your example, you can use the terminal, you type RQT underscore graph. Okay, then you can see like how the node and how they connect to each other, right? That will help you to visualize the connection between the node and also the topic. All right? Okay, so please go through this, make sure you understand this, and try to look at the publisher and subscriber, because tomorrow you might need to write multiple publisher, multiple subscriber in one single node, and that is quite challenging, especially when you have a lot of callback, for example, then you start to lose track, like don't know how the loops happen and so on. But that is actually the challenges that you're going to face after this. But don't worry, I will slowly introduce more modules so that you can integrate part by part, and eventually you will have a full service robot application. Okay, so today I would like to close the session for today. So if you have any question, yes, I will be still around. Anything that you want to ask now? Is there anything that you want to ask? Right. If no, then I will end the session here and I'll see you tomorrow. Okay, so please remember to do the exercise. And tomorrow we will show you more about the vision. And hopefully tomorrow morning I can start to show you the navigation as well. So that tomorrow afternoon we can discuss how to put everything together so that you can create a robot, like ask the robot from point A to point B, find someone, and then get some information and come back and so on. You can do this kind of application. Right? All right. Okay. So thank you, and I will see you tomorrow.
Thank you, Doctor.
那我们接下来聊这个动物。
对，是为了。